Hello, everybody. Welcome to our Get Ahead event 2023. Thank you all for coming. We're going to have a brief introduction from John of Shure, who's going to welcome us to the event.
Yeah, you're very welcome here. Thanks for coming out on this wet day. I think a lot of you have been here before, but some of you haven't. So this is called the Shure Rose Experience Centre, and that is after Mrs. Shure, who was Rose Shure. So back in 1925, when Shure was started, Sidney Shure started the company. He was the engineer, and fortunately he married a very good woman who was the business brains. And so this is after her, the Shure Rose Experience Centre. There's 3 experience centres around the world, one in Chicago, which is our head office area, and one here, one in Japan. But of course, we're the best, of course. So you're very welcome here. And just to let you know a bit of housekeeping, there's no fire alarms expected. So if there is a fire alarm, then we need to evacuate the building. And the nearest fire exit is through there and down the stairs and out the back. And if there is a fire alarm, we meet out the back in the pub over the road. Okay? All right? That's the muster point. But don't pray for a fire alarm, all right? I'm sure you get to the pub later. So yeah, you're very welcome. And we've got Andrew, who's helping with the tech at the back there. Andrew is our head of applications. Andrew Francis, you might know him. If any technical questions about any Shure products, Andrew's the man to go to. So you're very welcome, and I hope you have a great day. We're around if any questions. Rose and the rest of the team are here. Lunch has been provided and everything. So yeah, feel free. Have a great day. Thank you for coming.
Yeah, so we've tried very hard to put together a selection of presentations that cover the things that interest a broad selection of people from the Institute. So we're going to touch in turn on the subject of voice alarm, which is very popular with some of us. And then we're going to move into the assisted hearing technology area. And then we're going to wrap up with some audio-visual coverage. So one way and another, we hope there's something to interest everybody. I don't think there's anything much more to say at this point, except thanks for Roz for getting it all together. And I think without any more further ado, we shall begin with our first presentation, because it's that kind of time. So the first presentation is called The Challenge of Intelligibility in VA. It's going to be presented by Pawel over there. And Pawel works for Ambient System as technical director. He's very kindly flown over from Gdansk yesterday morning at an unearthly hour in order to be with us here today. And so I think with no further ado, I shall pass you over to Pawel's presentation.
Hello everyone. Can you hear me? Is it okay? Yeah? Perfect. So my name is Pawel Zakrzeswski. I'm a PA VA product manager, technical director at Ambient System. And today I would like to speak about challenges regarding delivery intelligible messages in modern voice evacuation systems, as well introducing principles of our new technology, which improves intelligibility in, to be honest, objective and subjective tests. That's why we've got the equipment to show how it works in the real situation. Little agenda of presentation. We'll remind ourselves of the core challenges of the voice alarm systems, recap the requirements of intelligible announcements, examine potential pitfalls when planning for the intelligible sound, look for solutions, introduce the new technology, which could be the nice armor of the add-on to the existing solutions right now. And then I would try to explain the 2 types of the algorithms and the devices which creates the active system. And obviously on the end, we will go through the live demonstration. So the main challenge of the voice alarm system, or to design the voice alarm system, is to find the right balance between the standards or equipment which is certified EN54, 16 for 24 for the speakers, and obviously we've got the BS in UK BS 5839 as a standard for commissioning, planning, and so on. And we need to find out the balance between the requirements of the client, building, occupants, find the solution, effective solution between those certified elements. And obviously on the far end we've got the first position, which fires basically the messages across the area, which is the loudspeakers design. So on the end we are doing the best to plan the speaker design, which for achieving the best intelligible messages. And the effectiveness of the PA-VA system depends on the intelligible of the speech. It can generate, briefly speaking. So we've got EN5432, as I said, which is similar, or it's based on the BS 5839, which describes the basic parameters, like the system has to the speech intelligibility should be not less than 0.5 STI. Then the level of the alarm messages should be at least 65 dBA. In BS it's actually 70 dBA. The level of the alarm messages should not exceed, for example, 120 dBA, to not make our customers, let's say, deaf. And the most crucial thing as well, we have to keep the signal to noise ratio, so broadcasted messages to the existing noise floor, which from, for example, EN5432 perspective, we need to give the space between 10 dB and 20 to get the best intelligible effect. In the BS standards, it states for the 10 dB headroom. And obviously, nowadays, often clients' requirements can now include additional audio tries, which confirm that message has been broadcast at a certain time and well received. So that's actually the new trick, how to achieve it. Yeah? So at first stage, to design the system which provides the intelligible coverage, we have to take into consideration many of the parameters, like reverberation time, ambient noise level, floor plans, surfaces, required areas to cover, and applications. For example, if we would like to play music, mounting arrangements of the speakers, and so on. So that leads us to choose the best type of the speaker at the first place, considering the parameters like sensitivity, frequency response, and directional characteristics. So that's the first stage to get, okay, the intelligible system. Yeah? Obviously, the second thing, which basically for the VA contractors that could be a bit too late, is based on the estimation or simulation of the spaces, we can suggest implementation of the passive acoustics absorption materials like panels, plasters, and so on. So many of them, because it's no much what we can do if the reverberation time is 6-7 seconds across the speech frequency range. But it's another solution. Yeah? And on the end, when we commissioning the system, we can only use or to get the best intelligibility to use the DSP available on the system. So applying the EQ, in some cases doing the time alignment if it's needed. For example, when we consider the tunnels, and obviously and on the end, actually the typical solution is use the ambient noise sensing, which is not ideal, but because it works on the full range of this of the broadcasted messages, but it's one of the solution. The issue is that none of those measures evolves and cope with the changing building parameters, like a number of the people, noise, which varies from the daily basis, or gradually alternation of the building features. So in the final situation, we set the system, we do the equalization, we set the volumes. However, that's the that's only for the time being of signing the system off. So in most cases, we need a live sound engineer, which twinkles the faders, adjust the level to get the best STI, using elements like signal to noise ratio around the 10 dB and so on, which actually it's not possible to have the sound engineer on site. Yeah, I'm actually sound engineer myself, so I can say that in most cases to achieve the best intelligibility coverage, I need to adjust the EQ, to have external devices like the noise analyzer, STI measurement tools, and using INS as well will help me. But unfortunately, we cannot afford a live sound engineer in every building where they would be useful. So we've got objective ways of estimation speech intelligibility and subjective. When we say about the STI, that's one of the objective way of estimation of speech intelligibility. And the main factors which influence the STI measurement is the sound pressure level. So it needs to be right. It cannot be too loud. It needs to be, because it degrades in the certain high levels above something 90 dB. It needs to be right signal to noise ratio. That's very important when you've got ambient noise. So you have to keep the effective messages broadcast and then above the noise floor, which we expect to be at least 10 dB to be on the to get the best effort. Reverberation time, it's not much what we can do about it, apart applying the passive acoustic panels and plasters. And obviously, frequency response of the modern PA systems, which are, in terms of the digital transportation, the whole path, they are high quality. Most of the leading providers of the voice evacuation systems, they've got a stunning quality of using either proprietary protocols for the transportation, or Dante or Cobra, and it's so many of the so many different protocols to get the high quality audio from point A to B. And obviously state-of-the-art amplifiers, and on the end we've got the speakers, which actually could be right now the weakest point in the whole chain. So Ambient System has worked with scientists from Gdańsk University of Technology to create the algorithms and devices which are able to modify spectrum of the broadcasted messages and unmask critical frequency for maximalization intelligibility and change the tempo of spoken messages without loss of the pitch, and in other side dynamically adopting the poor acoustic conditions. So that's the main goal which we're aiming with the SmartVest system, to do it something in the automatic way, which can without doing the lots of tweaks to get the best out of the voice evacuation system. And to achieve it, we've got few elements to do it, obviously. The system consists of the following components: microphones, measuring microphones, which measures mainly the ambient noise from the range 50 to 20 dBs. Frequency range is 20 kilohertz. Then this analog signal is going to the aggregation point, where it's digitalized and sent to the processor, which is SmartDU 1604. And then processor is implementing the algorithms called adaptive filtration and STTL algorithms, which I will describe slightly later on, based on the sensor readings provided from the microphones. And obviously, according to the BS standard and EN 5432, it needs to be fail-safe procedure, which is implemented when either microphones or aggregation point or processor will go offline or just be not available in the system. The processor itself can simultaneously process up to 16 audio streams, which allows to support adaptive filtration for 16 independent speaker zones. At the same time, the processor allows to implement the speech slowing down algorithm for up to 4 microphones at the same time. So for live announcements, so at the same time. And how does the system SmartVest works? Obviously, first stage is pairing procedure. So it means, in short way, we recognize where the microphone is connected and which speaker zone it serves. So it's an automatic procedure of knowing which mic is where. The next stage is collecting important system and room data. So that's what we call the calibration stage during the commissioning. So you hit the calibration start point, and on the basis of the 3 measurement signals played in sequence, like a STIPA modulated signal, sweep low pink noise, sweep high level pink noise, we can calculate and separate, let's say, the performance of the system. So how loud it can go in terms of the maximum SPL, minimum SPL. We can get the time delay between the microphones and the speakers itself. We can estimate the room properties like RT60 reverberation time, effective frequency response of the speakers itself. So the system knows where is the most effective bandwidth of the installation. And on the end as well, it gives back the value of the measured STI. So so it's exactly the same value which you are getting using the, for example, NTI XL2 when you apply the STIPA modulated signal, and you check the what's the STI of the on the given space in the using the voice evacuation system. So that's the first stage of the SmartVerse, and mainly we focus on the automation, not so having, let's say, engineer 24/7 available for you just in the processor. So having possibility to trigger the calibration procedure at any time, we can monitor the system and even actively activate the internal external warnings. So we can check if the message is properly received and register those parameters in the logbook, including historical values for each measurement, like the SPL, STI, system transition function, which can change over the time. So we can give that to the building management system or any external monitoring system for further examination. That's another benefit of the system. And during the normal system operation, so we've got the data from the room, how the system performs, and then when the system is commissioning, the microphone collects only the noise data, and DU604, the processor, has to modify speaker output based on the live data collected by ambient noise sensing microphones. That is adaptive filtration algorithm, which works autonomously. The algorithm changes the frequency response and amplification of the sound reproduced by the loudspeaker based on the calibration parameters and the current spectrum and level of the noise. So SmartVerse ensures the highest STI possible in the given condition online. Obviously, we have to set in the processor expected comfort SPL, let's say 70 dB, expected SNR, so we keep always the distance between noise and the broadcasted messages on the from 5 to 20 dBs. Updatation time is the activeness of the system, how fast it will respond. So that's one algorithm we implemented in DU, so called adaptive filtration. And actually, we've done many different tests in our acoustic lab, but on site as well. For example, we compare STI improvement introduced by the SmartVerse AF algorithm against typical INS and passive system. So orange, this is the normal passive system without volume attenuation. The dotted one, this is the INS system, and the blue is the application of the AF algorithm. So we had the different types of the speakers, from horn, active line arrays, projectors, and what is interesting in terms of the INS, we kept exactly the same distance between the noise and the signal. So it was, in that case, 12 dBs, and we measure the STI changing the noise floor from 50 dBA up to 105 dBA. And as you can see, from across whole ranges, you've got the benefits of the adaptive filtration on the compared to the wide or broadband gain attenuation. And what is interesting is that when we consider the horn speakers, despite its weaker performance and the low background levels, so it means the weaker performance, it means that INS it is really close to the smartest adaptive filtration. But what happens later, we can see very large improvement at the highest measured level levels of the noise. So from typical, when we crank up the noise floor to 90 dBA, from the given set of the attenuation of the speaker, we can get 0.54 when we use the INS and 0.67 when we use the adaptive filtration. So we can basically use effective bandwidth of the speaker, not before we maximize the headroom of the speaker. We as well tested the low power speakers, typical the ceiling ones and wall mounted. From the other hand, those let's say low power speakers provides better improvement and at relatively lower noise levels. So we've got a bigger span from, let's say, 75 dBA range, while the high power speakers, they extend in the lower, the difference between AF and INS extend on the higher pressure, let's say, levels of the noise. What is interesting, we were playing with the different type of the noises. Obviously, the pink noise, it's a broadband noise, but we tested what will happen when we place the narrow band noise, like a 20 kilohertz octave band, and we test one type of the speaker, which is LA. It's a line array system, line array speaker, slightly bigger than that one which we've got with in the room today, and that actually brings to the conclusion that we can, even with the INS in the really high levels, when we really close to between INS and adaptive filtration, and we try to push the system to the limits because the noise floor is so loud, then we are getting benefits across the AF using the effective speaker, let's say, effective bandwidth of the speaker. Yeah, when the INS just finish because it's gain entire range of spectrum of the frequencies, and the AF is using the basically 7-band equalization, avoiding, let's say, the band where the noise is existing to achieve the best STI possible. And the last algorithm, which allows us to improve the STI, it's from the subjective method. So subjective test of the logatomic expressivity. It is described in ISO 9921, dated on 2003. We perform a large group of we tested the large group of the listeners under 4 different acoustic conditions, including the operation of the STI algorithm. It has been shown that use of the STA STTA algorithm, which stands for Speech Temporal Transposition Algorithm, which is developed by the team of researchers of Gdańsk University of Technology and implemented by Ambient System, increase speech intelligibility in the reverberant conditions. So the speech temporal transposition algorithm naturally and evenly changes the pace of the duration of the messages spoken in the real time through the SmartVoice microphones. So the algorithm actually detects the type of the voice, male or female. It measures the rate of speech, and based on the values received during the calibration, so it knows what's the STI in the given area, it slows down the speech accordingly. So it's a dynamic speech pace change, but dependable on the situation of the area. So when the STI is below 0.5, then actually the change is significant. Yeah. When it's above, it will not do much about this because it estimates, okay, the STI it's good enough, so I don't need to basically modify anything in terms of the voice. And that leads us to the live demonstration over here. What we have is a control unit with the processor, and obviously amplifier, two types of the same speakers, A and B, let's call it. We've got the green cable tie, which represents the system which could be equipped with the AF and STTA algorithms. So it goes through the processor. It's a loop back between the processor and the control units. And speaker B, the red cable tie, is the basically typical speaker or system without any processing whatsoever. And for a bit of help, I've got the NTI measurement handheld, so we can compare the values, what we can achieve on the using our processor, and we can compare actually applying the different level of the noise if we are getting any benefits or not. And you will hear what's the standard settings, for example, for the speaker, and what the system is applying to the AQ during the calibration. Yeah? Okay, so I will switch over. Close that. Okay. So first thing which I would like to show you, I need to connect to the system. It's actually what's the calibration point? So what we have to do it during the commissioning stage to get those data from the room performance, system performance, and actually to calculate the STI and maximum SPL of the system. I set the system on the SPL 70 dB as a comfort zone, when and the SNR is 12 dB. So every time when I raise the noise generator, because I've got a kind of effective source of the noise, you will see how the system adopts and changes the volume and the equalization of the speaker. And we can compare it to the classical, let's say, system. So what you have to do, first of all, as I said, we have to verify if the microphone available in the system measuring microphone is listening to the right speaker zone. That's why we've got the pairing procedure. So basically, it sends every single, it detects every single microphone and sends in sequence the sweep noise to every single zone to recognize if the microphone is specified in the correct way. Yeah? So that's the first stage. The other stage, more important, is to proceed the calibration point. So that's when you have to. This is the sequence of the 3 different signals, like a STIPA modulated signal, then pink noise low level, high level. That allows the system to calculate this STI on the given point, maximum SPL, reverberation time, and transfer function between speaker and the room, and how effectively adjust the frequency bands to get the best STI measurement. The thing is that the calibration point has to be proceed in the low level situation. So low level, it means across something about 50 dBA, no more. Okay, it fails. It happens. I will do once again. Basically, when it tries to repeat it, it needs to do in the sequence. So it means that it couldn't meet the volume. Well, let's say once again, it needs to be silent anyway. Luckily, it finished. It managed to finish. So 3 different type of the signals. Now do the calculation and gives the value of the given point. Like it measures 0.85 STI, which is more like it because it's a well-treated room, and 87 dBs. This is the maximum SPL which the system can achieve. So it knows, okay, now what to do actually to reach the best, to get the best STI. And now we can actually compare the two systems with the AQ and without AQ. Yeah, so this one is calibrated, let's say, the same type of the speaker, the same tapping, the same amplifier channel, and with the algorithms and without. Yeah, and I will play simple message to the first, let's say the classic system.
May I have your attention, please? May I have your attention, please? The fire alarm system is about to be tested. Please do not take any further action.
And we can compare with the calibrated microphone, speakers.
May I have your attention, please? May I have your attention, please? The fire alarm system is about to be tested. Please do not take any further action.
Can you hear the difference? That it's less boomy, it's more top end, it just adjusts the auto equalization, and straight away it drops the level because it detects the noise floor. Yeah, so now you can switch to the real measurement, and we can apply the noise to it and see what's going on. So for the sake of presentation, I've got the pink noise. I've got the different noises as well. We can try, but let's try. So it's the generator, and on the given level of the STI, we can compare the STI measurement. Yeah. So first, I will measure the calibrated system, and then we will compare with the let's say standalone standard system. Yeah. So I will activate the STIPA signal to the, let's say, calibrated system. Ah, forgot about noise. Sorry. So you can hear straight away it's applying EQ. Sorry. I will do it once again. Let's finish. So 0.75. And the normal system . So clearly we've got 0.72 against 0.54, yeah, in the automatic way. So, and you can hear the difference when when I just play the different messages, and I will crank the noise floor, and you will see the equalization and the volume change at the same time. Yeah. So let's say I'll play the same test signal to the zone.
May I have your attention, please?
And then I will apply.
May I have your attention? The fire alarm system is about testing. Please do not take any further action.
Yeah. And then.
May I have your attention, please? May I have your attention, please?
Yeah, so it responds quite quickly to adjust to keep this 10 dB STI threshold. Yeah.
May I have your attention, please? May I have your attention, please? The fire alarm system is about.
Okay. So that's the objective way how we can actually show improvements. STTI, this space algorithm, changing algorithm, it's a subjective way. So I cannot show you the difference on the STI measurement. However, I can play very fast messages, because it doesn't matter if the system is getting audio or messages through the microphone or through the jack in. So I've got actually the Google generator, which I can speed up the message, and we can compare how the system is able to slow it down without changing the pitch. So to do it, hopefully it will work. So let's say I'll set the speed on 1.71.
May I have your attention, please? May I have your attention, please? Fire has been reported in the building. This report is being investigated. Please remain at your workplace whilst the fire alert exists.
Yeah, it's quite fast. So that's through my noise noise generator speaker, and now I will send that to the system, which is zone 2. And jack is the microphone in. Now we'll play exactly the same thing.
May I have your attention, please? May I have your attention, please? Fire has been reported in the building. This report is being investigated. Please remain at your workplace whilst the fire alert exists.
I cannot hear the difference, to be honest. Ah, yeah, because I didn't apply the speech algorithm. So that's without. Yeah. Woof. Yeah. That's the reference, let's say, yeah? So now, so good that you can hear the difference. Now it should work.
May I have your attention, please? May I have your attention, please? Fire has been reported in the building. This report is being investigated. Please remain at your workplace whilst the fire alert exists.
Just a bit, yeah, because it's, I have to adjust the system to the, because over here it's a STI quite high. But can you hear the difference? Yeah, I hope so. So that's basically didn't change the pitch of the voice. It keeps exactly the same source. It just slows down. It is all about rating the speech. It needs to let's say the German, English, and Polish. They are completely different ranges of the languages. So you need to determine the right speed of the vowels and consonants, and to keep everything in a natural way. So that's what the processing is doing. So adaptive filtration and modification of the speech at the same time. Yes. Yeah. Yeah. So it's basically it's the change is related to the STI and RT60 achieved by the microphones.
So if you add in your noise, will it adapt to that as well?
Yeah. Let's. Okay, I've got the same PC connected. Just wait a second. Let's do the trick. I will generate the same thing through the mobile, hopefully, and I will apply the noise to it. Yeah. It could be the different message. Okay. Okay. That's applied. Second DNS. I have to switch to zone 1, which is the adaptive filtration as well. So give me a sec.
Well, if adaptively slows down the speech when you're noisy, not in the
It's two independent algorithms. So
well, you obviously the spectrum that changes obviously related to the noise, but whether it bothers to slow things down when it knows it's
so basically it's based on the STI value. Yeah. So if it measures 0.8 in the given area, it will not change anything in terms of the pace. Even when it's obviously you cannot get a 0.8 STI when it's high reverberant space anyway. So, but the whole idea is that you can have a adaptive filtration and pace change, or you can separate those elements having different spots of the installation. Yeah, so that's how it works. Yeah. Okay. Thank you.
Pawel. Thanks very much. Thanks very much, Pawel, for your for that. It's always a very scary business coming to a presentation and actually demonstrating, taking the risk to demonstrate some technology.
Yeah.
Do we have any questions? If we have questions, because we have people joining us online, welcome people online. Anyone wishing to ask a question should ideally use the microphone. Do I have any takers from the audience? We'll go with Paul because he's in the front row. There we go.
So if you're relying on the clever algorithms and a CPU to achieve your STI requirement, how compliant is that with 602.118 and 5839? How do you assure it? How do you say, well, here's on my traceable calibration certs? This is
okay. So the system is certified. Actually, it has the BS EN5416 certification, and actually the EN5416 has no scope this kind of the changes at all. Yeah. Now we can see the change. Basically, when you consider EN5432 BS5839, then you can see the bits of those elements in the commissioning, testing, and planning procedures. So in terms of the legislation right now, it's completely legal certified system. Yeah, because it doesn't say, because it's old standard, it doesn't say anything about adaptive measurement and adopting the life situation. It's the future, let's say, of the certified systems. Yeah.
And am I right in saying that your calibration process, the ground noise has to be 50 dB or lower?
It needs to be performed in the low level noise situation. Yeah.
So if you can't achieve 50 dB, then you can't calibrate.
Basically, so when the room is, let's say, louder than this, and you cannot switch the noise floor, let's say, it is a way to get it. It's called safe procedure of the phase safe situation. So you can get the calibration procedures, let's say, in the worst case scenario, which then the system expects the not 50, but it doesn't look for the 50 dB limit of the noise floor. It just takes what it gets from the microphones. Yeah? But it's called phase safe procedure. Yeah?
Okay, thank you.
But it's a very good question, to be honest. And the same with the STI measurement. The STI measurement, it says that you have to collect the noise and record the noise, and then do the STI measurements, and then you're doing the let's say split of those signals to get the STI measurement or value. So this is based, this safe way procedure is based on those purposes of the real STI measurements in the real situation. Yeah?
Another to a Paul or Pawel. So just to follow up on probably most of those. The first one about the point about if we can rely on this within the codes, but if you're saying it's the processing for this sits within a system that is already EN5416 certified,
yeah,
then we can take some assurances from that it's not going to fall over at a critical moment for all the same reasons as we can for all the other elements of the system. So that's a good thing.
Yeah.
Yeah.
Obviously, everything can.
Yeah, absolutely. No, I get that, but as much as anything else.
And you get the phase safe procedures. Basically, the system will go maximum.
So that kind of puts paid to any argument that says, but in order to get the performance that you say you can get, you rely on an element of the system. But if that element of the system is covered by certification, then we can be as assurant about that as the backup power supply.
Yeah.
So that's good. What was the second point you made? Oh yeah, about Oh yeah, but when you have a situation where you can't go below a certain point, well, I'd imagine an industrial hall would be an example of that, where you can't switch the equipment off. But if you never go there anyway, if you've never gone that quiet, then your situation, your setup would be fine, because it's never going to be that quiet. So you're dealing with what you've got and possibly worse.
Yeah, and the real situation is that you're doing the tweaks, you're signing off the system, and you never touch it. And that's the thing. And then you've got a building, construction, changing the walls. I don't know, everything changes completely, but the settings are way out of date anyway. So that keeps you updated. That's the main thing, keep you updated.
So I'm more instantly thinking about how this might work in a stadium situation. And a couple of things come up. One is the adaptive filtering obviously it's laser guided on getting the best STI. Yeah. And obviously for an emergency, that's exactly what you want. But there are
live performance.
Well, not necessarily live performances. I'm not talking about. I'm talking about, say, during a game. So the announcers during a game, for example, where you still want a bit of that intelligibility, but you probably don't want to be as harsh about. So in other words, you've got a slightly different set of priorities, which and those priorities would depend on the input. So the commentator's mic would be one set of priorities, and an emergency mic would be pretty much the one you showed us here. Is that something that's a variable within the system that you can kind of give it a different basis?
That's the future, to be honest. Obviously, we are looking for the wide range of the applications, but now it's prepared for the voice evacuation systems. Yeah,
I can see a lot of value.
The thing is that because it's we have to create the internal acoustic loop. So we're gathering data from the microphones, and then the audio, digital audio, instead of going to the amp, it has to go to the processor. Then it's combined, prepare, and back to the amplifiers. It limits as well the use of the external systems. Because then we have to figure out, the calibration procedure, the analog in-outs, and so on. It is possible.
That was the other consideration.
That's the future.
That was the other consideration as well, to do with the slowing down of the speech when you've got a live announcement. Obviously, that's tricky, but still interesting. Very interesting application. Thank you very much.
Jim.
Just quickly, I'm curious about the positioning of the sensing microphones. If you're in an exhibition hall, let's say, where the roof is 10 meters high, and you're taking your measurements up there, the listener is 8 meters below that. Mm-hmm. Is there any compensation in the system to accommodate that?
The placement of the measure microphones is quite crucial. It needs to be, let's say, between 5 and 10 meters from the noise source, and 5 and up to 5 till 10 meters from the speaker. Closest speaker or estimated geometrical in average geometrical distance between the arrays, let's say. That's the first starting point of the placement of the microphone into the system. However, because the system is patented, it's actually protected by the patent, and we've done the test how the placement of the microphone influenced actually the measurement and the effectiveness of the system. And it turns out actually the height is not the issue. The height is not the issue. The only issue is that the system has to properly recognize the speakers, or generally the speakers which has to control, and obviously be as close as possible to the noise generator, the source of the noise. So that's actually 5-10 meters between the speakers and the noise generator. That's the first starting point for the design.
Questions keep coming. By the way, if there's anyone online wanting to, no, we're good. Okay.
Hi, Pawel. I wonder if you've got any installations of your setup that you could offer us as a case study. Anywhere you're particularly proud that it's been installed and working effectively.
We do have first one was obviously in our new headquarters, where we've got big offices, spaces, let's say staircases with really absolutely shocking bad acoustic. It's like 6 seconds of the delay with cumulated between 125 hertz up to 300 hertz. So basically you cannot hear Neil speaking to me being 3 stairs above. And we've got now, let's say, reference systems being deployed as we speak. And the first one is the, let's say, the spa resort where we place actually this technology in the swimming pool area for the to get the best, let's say, background music experience. So that's coming, and we've got a few more, but it's related to the theaters as well, where you cannot adapt or get any passive acoustic panels and stuff like that. So, and they had the issue with to achieve the STI on the expected levels. So we've got a few coming. It's I think to the end of the year, it will be like a nice 5 sites which we can show. Yeah.
Everyone's talking about AI at the moment. Do you see AI helping you in the future?
In some extent, yes. The thing is, we have to find the way to actually to show what we want to achieve, not in the digital, in the figures, but it needs to sound for the human being. So that's the issue. It is future, but we're not there yet.
Okay. I think this will have to be our very last question because we need to try and keep on timetable, but please.
Oh, thank you. Hi. I just wondered what is average cost difference between a standard evacuation system and your smart evacuation system, just roughly as a percentage. And then I think the second question that moves on from that is what is the percentage of difference in STI, an average percentage difference between a standard evacuation system and the smart evacuation system?
It's what I showed on this different speakers. More or less, we're shooting maximum 0.2 STI improvement. That's in the real world when we've got, let's say, 0.38. The situation, we applied the processing, the microphones, let's say whole elements. We're shooting above 0.5. Yeah, to reach the, you know, those small difference, but to be on the safe side or not. Yeah, to be on the understandable or intelligible way, or not so much. Yeah, so that's the first thing. In terms of the costs, the thing is that this is just adding the to the standard system the processor. That's the biggest cost, and the aggregation point and microphones is just it's not actually cost heavy in terms of the entire system elements. So I would say it's hard to say because you've got three additional bits, let's say, or more microphones. However, we can basically we can limit the number of the amplification which is needed to achieve the right SPL. Or basically you can have a amplifiers rating not wasted, being accurate, and from the other side we can have a power supplies. In our system we've got the power supplies related to the number of the amplifiers, so it's a kind of external device. So when you consider the number of the amplification and the less power supplies for it, it could be the same, or it could be the same. Yeah, I will not say cheaper, but the same level then. Yeah, it's hard to be precise. Yeah,
I guess it's
yeah.
Okay, Pawel, one round of applause. Thank you very much. And we take 2 minutes. We're going to have a 2 minutes, 2 or 3 minutes for a comfort break for those needing it, or for a refill of your cup of coffee or glass of water, or we change the stage, and we'll be back with you in a few minutes. Welcome to our second presentation, which will be given by a man who needs no introduction, but we'll give him one anyway. Dr. Peter Mapp, speaking on his update on assistive listening systems. Peter.
Thank you for that lack of introduction. That was wonderful. One of the best lack of introductions I've ever had, actually. Excellent. Yeah, that was well done. Thank you. Yeah, all right. Let's get going. I apologise beforehand for this being not the most dynamic of talks. I'm still recovering from some major surgery and I'm absolutely knackered at the moment. So if I fall asleep halfway through, somebody could wake me up, because I won't even be aware. Okay, so assistive listening systems, they've got to hit the headlines again for various reasons, some good, some bad. And there's some things going on, and there's an awful lot of uncertainty and misinformation and hype going around, so I thought I'd try and cut through some of that and get to it and see where we are. So that's the intro. So you're going to see that comment coming up several times during the next hour, and you'll understand why as we go through. But it's not unreasonable that intelligible audio, it's not a privilege, it's a right for people to be able to hear, especially if you've got a hearing impairment. And again, I'm going to talk about it from the hearing impairment side as well as the technology, because it really is important. And providing an ALS is not just a question of ticking a box, although in many situations that seems to be the case. There's total lack of empathy and understanding of what the hearing impaired actually need. And I am absolutely staggered at times at this. I mean, it really is quite appalling. So let's have a look. So hearing loss affects about 12 million people in the UK. Well, that's a hell of a lot of people. That's not a minority. That's a lot of people. And it's not unreasonable that they should be able to hear properly or given assistance. You know, and there are 54,000 registered deaf children in the UK. Again, that's a lot of kids that need assistance. Sorry if I really get quite worked up over this, because it really does get to me. Okay, so the other thing that people don't understand is that hearing aids only have a range of about 2 to 3 meters. People seem to think you've got a hearing aid and you can hear half a mile away. You know, I mean, take it ridiculously, but you can't hear with the hearing aid to the end of back of this room properly. You know, they have a limited range of about 2 meters. Sometimes it's 3, sometimes it's only 1.5. Depends on the hearing loss as well. So it's very limited. Yet that has not got through to people, and that's why we need effective assistive listening systems. Not only that, once you've got a hearing aid, it's only partially restoring your hearing. Just because you've got a hearing aid, you are not getting 100% your hearing restored. Far from it. If you're lucky, you get 50% back, 50%, and you've probably got distortions and other things going on as well. So just because you have a hearing aid, you'll still have hearing impairment to quite a high degree. And that needs to be understood when people are actually installing systems and specifying them. So if you've got a hearing aid still, you're still at a significant disadvantage as opposed to people who don't have hearing impairment. And that is, quite a significant disadvantage. And particularly so in noisy environments. Noise is the killer for the hearing impaired, with or without a hearing aid. And hearing aids, they're getting better, and some of them have got some noise suppression in them, but it's pretty ineffective in reality. In the future, it's going to get better, but at the moment, even with the latest digital technology, it's not very good. But the point is, with an assistive listening system, we can overcome some of these issues and help the hearing impaired by effectively bypassing the acoustic space, by bringing it straight into your ear. But it needs to be high quality audio that we're actually giving them. And again, that's not really understood sometimes. And again, I'll show you some examples later on of systems that really didn't work. Also, assistive listening systems are very useful for listeners who don't have their own native language, aren't listening in their own native language. Really quite an improvement. I'll show you. I mean, I do some intelligibility testing at the university I'm involved with, and if you want, it's about a 0.1 STI difference. So we might get 0.5. They're actually listening to come to 0.4. Although they've got good hearing, it's just the way they listen. And now you have hearing impairment, and you're also not in your non-native. You know, you're not doing very well. So we really do need to make sure that assistive listening systems are effective and doing a good job. And it's dreadful that less than 25% of hearing device users, i.e. hearing aids, are told about other accessories and things like loops, for example, and assistive listening systems when they get their hearing aid. Less than 25%. The audiologists actually are doing an appallingly bad job in that respect. I mean, I'm sure, you know, that in terms of your hearing, they know a lot about it. They know absolutely sod all about loops and assistive listening systems. They don't even know what they do. Most of them don't even appreciate that a hearing aid doesn't work more than 3 meters when you talk to them. I mean, you know, I find that quite staggering. Okay, so let's have a look at some of the technologies that are available, and then we'll go through some of the hype and some of the other issues. Well, I mean, hearing loops, AFILs, they're now called hearing loops, are traditionally in the UK. That's what we mainly use. We've had for years and does very well. Infrared has also been around for a long time and is used in various applications, particularly in theatres and those sort of venues and auditoriums, and as you'll see later on, in another system. Audio over Wi-Fi is the new kid on the block. It's arrived in the last 2-3 years, really, I guess, and is sort of taking over, and we'll talk about that in a bit. There are radio FM systems. In the UK, they are very, very rare. So I'm not going to talk much about those, but they are there. Bluetooth is also used in assistive listening, i.e. between maybe your neck loop and your hearing aid or some other system or some personal system. Bluetooth is used. That's traditional Bluetooth. We now have Bluetooth LE and Auracast. And this is the one that's causing quite a stir, which in one hand is quite good. On the other hand, it's actually very bad because people really don't understand what the hell's going on. And hopefully I'll get through that to you. Also, a thing called sound field systems. You've probably not heard of these, but these are basically a kind of a small reinforcement system, sound reinforcement systems, particularly, but used in schools and classrooms in particular. That's their area. And we'll have a look at those a bit later on. And then there's some personal listening devices that are not hearing aids, but they may feed into your hearing aid. Maybe it's a microphone you remotely put on the table in a meeting, and it feeds into your hearing aid, for example. And some of those are really quite sophisticated. Some of them have got some switchable microphones, selectable microphones, beamforming microphones, noise reduction. They really are getting quite good. So they're very useful to use, but they're not a system. So I'm not going to talk about them today. I don't want to talk about systems, but they're there, and you need to be aware of them. That's kind of really preempting the whole of the talk. Why do we need some guidance and a code of practice? Well, you're going to see. I'm going to build up to that. But I'm asking the question now so that it's in the back of your mind. Well, the answer is so that the hard of hearing and hearing aid users can gain a useful hearing benefit from their assistive listening system. There's no point in having an assistive listening system if it doesn't actually do the job. It's just like having a voice alarm system that you can't understand a word. You know, same thing. Except people seem to understand that voice alarm systems should be intelligible. This is not quite as widely known, hence the thing. So really, it's a bit like the Wild West at the moment in terms of assistive listening systems. It really is. There are kind of no rules, or very few rules. And those that there are there, people are kind of ignoring or whatever. So let's have a look. I mean, a good example of this is we brought out the loop standard in 1993, so what, 30 years ago? Is that right? Yeah, do me maths right. Exactly this year, funnily enough. And that actually brought about quite an improvement in loops. up until then, I mean, that is a real measurement I did in the early 90s. If you could get to a kilohertz on a loop, you're doing well, the way they were designed. You know, nowadays we've got to get to 5K, and there's no reason why you can't, and most do, or should do anyway, which is a dramatic improvement in intelligibility for things. So that was really brought about by the British standard 7594, and that really did single-handedly make quite an impact and do something. Unfortunately, it's been forgotten, but every loop amplifier out there today now is a current drive loop amplifier, so it actually improves the situation. Whereas before, we used to have, to get the impedance, you just used to use any old amplifier, and then to get the impedance up so you can match the amplifier, you'd use like a 5-core or 7-core multi-core cable around the room to get the impedance up. Hence, you couldn't get beyond a kilohertz. That's a real measurement using a multi-turn loop from you know, way back when. So things have improved. So it does show, or does suggest that if you have a standard, you can actually improve things. So you know, ignorance is bliss. If you don't know, then whatever. So you can say, well, why are people ignorant? Well, maybe we should do more to teach them, to train them, to make them aware. I mean, not only is it bliss, but it's an absolute impairment to the hearing impaired. It really is. So let's go through some of the things. Only hearing loops have got any detailed performance standards with the ALS. Nothing else has, which is why it's the Wild West. Infrared systems have got some standards, but there's no real user standard for it. And there's lots of things that they don't do and should do properly. Audio over Wi-Fi, there's no standard whatsoever, or user requirements to meet, so you can do what you like, and people do. Radio systems, there's no standard. Bluetooth, there's no standard for the Bluetooth systems, but they're generally personal ones, so I'm not too worried about it. Now, BTLE and Auracast, there's no current standard, but there will be. Auracast are actually producing standards for their own systems, but it's not for another 2 or 3 years. I mean, they're starting. The first meeting is next year. So when you talk about Auracast and it's being available, no, there's no standard for it, so nobody knows what to build and how to build it and what the protocols are and how it's going to interface. And it's going to be at least 2 or 3 years before that information actually becomes knowledge, you know, it comes out and does stuff. So it's a way off. And sound field systems, again, we're not going to talk about very much, but there are no standards for those either. So there's only loops that have got any standards at all to actually make them perform properly, or, you know, you can hold up against. That's why we need code of practice and some guidance. Slight aside to this, some demographics and hearing aid stigma. If you talk to the younger generation, i.e. millennials and Generation Z, they have a completely new view about hearing aids and to the older generation. They see it as a stigma. If you're wearing a hearing aid, they don't want to wear a hearing aid. They're more than happy to have ghetto blasters stuck on their ears. That's no problem at all, but you can't have a hearing aid. Whereas the older generation want a hearing aid, and they want a simple, direct means of accessing the technology. They don't want to have to use a smartphone or some other device and have a degree in computer engineering or whatever, or have a 9-year-old child next to them so they can actually operate it. You know, and there really are two polar differences between the populations. And there was a survey done a couple of years ago, and only about 8% of hearing aid users actually wanted to use some intermediate device, i.e. not their hearing aid directly, which you have to use if you're using Wi-Fi, infrared, or Auracast at the moment. Well, you can't use Auracast at the moment because it's not available. It was interesting. I just happened to find this the other day, that Mattel last year actually brought out a Barbie doll with a hearing aid. So maybe the stigma will start to go away a bit. You know, if Barbie's got a hearing aid, then maybe that starts to get through. The trouble is, putting an old person up there with a hearing aid makes no difference, does it? Because I mean, that's expected. But it's not expected for the younger generation. There's another doll I found with a hearing aid. I don't think it was very effective, actually, but never mind. I didn't test that one. So let's go through some types of ALS and some of the issues with them. So let's start with hearing loops. Traditional, T symbol, that's well known, T for telecoil. And that's the one that we traditionally use in the UK, and there are thousands of systems out there. Some work quite well, some work not so well. The major advantage is that the loop signal can be picked up directly by most hearing aids. I mean, those with a T-coil in them, which is at least 70% of what's available. So it's straight into your hearing aid. You don't need another device. You don't need a thing on the top of your head to do about it. It's straight in, dead easy. And it is giving you the right signal because it's the prescription signal of your hearing aid that you get. These other systems with headphones and things don't give you your prescriptive signal system. And I'll give an example later on. So I said the COP was introduced in '93, and that's led to a good improvement. There are other standards now. There's 3 international standards effectively. This 601.184 is the main standard where it's all laid out. Trouble is, it comes under hearing aids and acoustics when you look at it, so you've got to go looking for it. The one on the N62849 has some other or additional information. For example, that's where the standard for neck loops is, and some other 2 bits and pieces to do with that. They're not together. And then there's TR63079, which is a kind of you can't have a code of practice within the IEC. That's not permissible. So TR63079 is effectively half of the old BS standard, with bits removed that the Europeans didn't like, which is some of the useful bits, but there we go. But nobody's ever heard of it. Nobody ever uses it, unfortunately. Infrared, quite widely used still, although it's waning. I mean, there is no symbol actually for infrared, so we've sort of come up with one that vaguely, I mean, you could use all sorts of things, but we've come up with that one. So it's very common in theatres and concert halls, those sort of areas. Indoor arenas where you can get a good coverage easily is a good way of doing it in the UK. But you need a neck loop or some sort of device to actually hear it. There are some IEC standards, but they don't really cover the use of it in terms of the user. Let's talk about Wi-Fi, audio over Wi-Fi. Again, there's no symbol, but we've come up with a thing that might kind of give people an idea. Because if you turn up somewhere, you want to know what the system is. Because it may be, well, okay, it tells me I can't use my hearing aid straight away. I'm going to have to go and get a device to listen to. Or maybe I've got one. You know, I go around with an infrared system as well as a loop listener. So I can listen to things and see what they're doing. So IR infrared is waning a bit. Sennheiser are no longer, for example, making IR transmitters and systems, but other people are still, and there's still a market and they're still useful. And in fact, you're going to see in a few minutes there's another use for them that people won't maybe thought about. And so there seems to be a gravitation, certainly in theatres, to audio over Wi-Fi. And we'll see some of the issues that might bring. But I've got to say, the success of audio over Wi-Fi is very variable. Really is. Okay, Auracast. Let's talk about that. There's the symbol for Auracast. You will be seeing that a lot more in the future. It's a Bluetooth system, but it's Bluetooth LE. It's a low energy system and has got rid of some of the restrictions associated with Bluetooth. It's on the horizon. It certainly isn't available yet, despite the hype that you read in several of the magazines. I think there are 2 products so far that are made that are vaguely Auracast compatible. And I say vaguely because the standard hasn't been written, so how can they be? You know, so the other thing is that you can't, in an IEC standard, call something Auracast. So now it has to be an assistive listening system for hearing aid users based on a 2.4 gigahertz audio streaming. In other words, Auracast. So you read this, there's the preliminary data for the standard, and it says all that, and then about the second line it goes Auracast. You know, but that's okay. It's not in the headline. You know, you can do that. But it's going to be an interesting next 2 or 3 years getting Auracast into a shape where it is usable. You know, for all sorts of things. Traditional Bluetooth is a one-to-one. That's the real one of the limitations of it. And it's got about a 10-meter range, typically. And it's very heavy on batteries if you're using it with a hearing aid. The new Bluetooth, LE, which is 5.2, I think, it's more efficient, so there's far less battery drain, which is a good thing. It's got a greater range, up to maybe 50 meters, depending, but it's going to be of that order, so it's a big improvement. It's also one-to-many, and this is the real clincher, because now instead of being one-to-one, it's one-to-many. So it can be like a loop or anything else. It can be one to several hundred if necessary. So you can just log into the thing, and it will stream the audio. It also has lower latency than Bluetooth. It's been notionally set to 50 milliseconds. Quite what that means, we don't know yet, but at least they are talking about it, and they've set a number that's looking in the right ballpark, as you're going to see in a minute or two. And yes, there is a standard. I mean, it's been allocated as a standard number, so things are actually going to happen to that in the next while or two. The other thing is it's going to be used not just for hearing aids, although that was the original idea. There's a far bigger market in other areas where you can use this technology. In fact, and if we're not careful, they're going to drive how auracast occurs. And so therefore we have to be very careful and have a very strong voice to make sure that it still does what we need for assistive listening systems. Otherwise it will disappear and not actually be fit for purpose. Okay, brief thing on sound field systems, just so you're aware of them. Basically, you have a classroom, typically, and you put some speakers around it, on the ceiling, on the walls, wherever, to get a distribution of sound. Simple as that. So it's a little sound reinforcement system, but if you call it sound field, you can charge a lot more money, basically, because it has a name. Sorry, I'm cynical at times. So it's a special type of assistive listening system associated with schools and classrooms in particular. The teacher has a wireless mic, which can be an RF, a normal, typical RF radio mic, or it could be infrared. And a lot of the systems out there actually use infrared for all sorts of reasons. So, while these are around, infrared is still very much available. And the objective is to produce an even sound field throughout the loudspeaker, throughout the room, which it can do. But the trouble is it's often mistakenly used to overcome poor acoustics because it's an easy retrofit. Bung 4 speakers up, whatever, fine. If the acoustics are bad, all you've done is manage to make it bad everywhere. And in fact, you can make it really bad, but very evenly just bad. So if you believe in democracy, you can have it bad everywhere, and that's the point. And they can work really well, so there's both sides. But just because you put a sound field system in doesn't mean it's going to be effective, as is the case with any assistive listening system. So we need good acoustic. And it basically amplifies the voice of the teacher to overcome signal-to-noise ratio, because classrooms can be a bit noisy, or just to get to the back of the room. A day teaching, teachers' voices do get strained, and they're doing quite a lot of work on that. And you need an STI of at least 0.6. At least. I would like to see it a lot higher, but you've got to be realistic. If it's less than that, there's no point in doing it, frankly. There really isn't. And that's the classroom acoustic standard. So I'd say there are no standards for it. That's my kind of view of what it should be. And anybody wants to argue with me, and then please see me outside, and you will lose. But there are no standards. So that's where we go with that one. So that's enough. The other thing is that, again, there's no symbol for it, so we've come up with a symbol, which seems to kind of work quite well for that. And also, you've got an infrared transmitter and also a receiver, obviously, from the microphone, but that can also go straight to the students, so they can wear a neck loop or whatever, a receiver, and get it that way, so it goes directly, so you don't have to worry about the room. Just to give you an idea of how effective some of these systems are or not, these are real intelligibility measurements, not STI rubbish. I could say that. At 2 meters, we're getting about 90% intelligibility for sentences. That actually isn't that good, but it's okay. Once you go 4 meters away, you're down to sort of 50, 55%, which is abysmal. It's only 4 meters. And once you get 8 meters towards the back of a classroom, you're down to sort of 35%, which is worse than abysmal. If you can, I'll let you come up with the adjectives for that. But it's only 8 meters, which is in most classrooms, that's not at all untypical. And this is a really good classroom. It's got an RT of 0.4 seconds. Bloody good. You can't get better. And that's the kind of the situation we're in. This is why we need a decent system. And if you do some other intelligibility testing, these are non-native listeners, children, in this particular case, which makes that point quite nicely. And there you see, it's a slightly different graph, different occasion, but you can see the same trend. You know, if you're in 2 meters, you're okay. If you're at 4 meters, forget it. They're not going to get it. Put a sound field system in, and whoa, everywhere is basically the same because it's trying to do that. In fact, you're worse off at 2 meters, but at least it's 80% everywhere. So it actually is quite effective. We would like to see it better than that, but at least everywhere, the back of the room or wherever you are, you get a similar system. And this is acoustic, not via whatever system. So let's have a look at the effect of noise on speech. I mentioned it was one of the worst things to do. I'm sure we've all sort of seen information points and help points in noisy situations. And by having your hearing aid and getting straight into your hearing aid, you can bypass the ambient noise of the station, airport, or whatever. And this is a really nice example of that. This is a trace in real time. This is, if you were to listen to, this is actually a PA announcement in an airport. And it's all nice and fuzzy because that's all noise on top of the announcement. And if you listen to that, you can get about 1 or 2 words out of that. It really is quite appallingly bad. That is exactly the same signal now heard through a loop system with a microphone straight with a PA mic. So that's a feed straight from the PA mic into a loop system. And you can see, now you can see every detail, you can get every phoneme, you can get every syllable without any problem. And the improvement is something like less than 5% intelligibility there, and you're up to over 90% intelligibility via assistive listening system. It doesn't really matter which system it is, as long as it's a good one. That just happens to be a loop. But that just goes to show the effectiveness of these systems if they're done properly. The biggest problem in a lot of these systems is the microphone. It's the weakest link in the chain, and people still don't seem to get it. You know, it seems to be, oh, we'll put a microphone in the room, doesn't matter where, and it'll pick it up, it'll be wonderful. No. So let's have a quick look at that. Again, microphones have got a typical pickup distance for assistive listening of a maximum 2 meters. If you're further than 2 meters, all bets are off. You know, it's not worth doing in most rooms. So I can't talk and drink, that's quite interesting. You'd thought after a lifetime of doing it, I'd realise that. Meeting rooms, typically 0.5 to 1 meter. The microphone has to be within that distance. If it's further than that, ain't going to work. Just hear up too much room reverberation and noise. Cine mics, again, have to be in 2 meters. So if you put a cine mic at the back of this room, which is I've seen in classrooms, it's not going to work. It can't do. Even with a good acoustic environment. You can now get beam steered microphones. Various manufacturers make them, and they can be really good. I've listened and tested a couple and was really very nicely surprised at what they can do. And you can extend maybe the distance to 4, maybe even 5 meters in a room like this. But they're bloody expensive. You know, you're 2 to 4 grand for a microphone. You know, so it's not going to be in everybody's system, but can be very effective. Gun mics are used a lot in theatres for picking up the sound. To a greater or lesser extent, we will see. That's just a quick diagram. Came up with this years ago, just showing if you use a more directional microphone, you can get further away. But you can't get more than 2 meters anyway, so actually, it doesn't make a huge difference. But cardio mics are generally better than omnis for that. And I'm going to skip that. So let's have a look at some real systems. This is a gun microphone. It's difficult to see, but it's actually a reasonable sized gun mic. That is picking up from a lighting bridge the sound of the stage in a theatre. except it isn't, because it's actually pointed towards the back of the room, away from the stage, and that's why the system wasn't working very well, because that's where it was, and nobody realised. I mean, it didn't. 5 minutes you go in and you find out what the issue is. Point the bloody microphone at the stage, you know, at the people. You know, it's like I used to say, point the loudspeaker at the people. Now it's point the microphone at the people. You know, I mean, it's a really simple rule. It really is. It's dead simple, and keep it within a reasonable distance. If you're doing a meeting room these days, architects love hard surfaces like glazing. You can see here you've got glazing on both sides. You've got a hard ceiling. You can see by the reflections on it. And you may or may not get carpet on the floor and a big reflective surface. So these can be really quite nasty rooms in terms of acoustics for picking up speech. But if you get the microphones close enough, you do need several of them, it can work fine, no problem at all. Now this one was an interesting one. This room was refurbed, it was a meeting room, and it was a meeting room that was used by the hard of hearing people a lot in this particular venue. And they had a couple of semi-intelligent, talk about artificial intelligence, these are semi-intelligent microphones. I think they have an IQ of less than 50 by that, because as soon as they used this system after they got in, there were vociferous complaints about how useless it was. You know, they are too high in the wrong place and the wrong type of mic, and yet they'd spent a lot of money trying to get that right. You know, just because you spent money doesn't mean to say it's going to work. You have to understand what it is you're doing. This is a microphone on the front of a balcony in a nice traditional theatre, beautiful place, but it's 15 metres from the stage, front, let alone for the back, and useless. This was a gun mic, really nice gun mic, very expensive gun microphone, love it. Stuck right at the back of the room, and this is, you can see, it's a reflective, reverberant space. You couldn't understand a ruddy word. You know, I couldn't, let alone somebody trying to listen through a assistive listening system. And then you get this case. Here are two gun microphones on the side balconies aimed at the stage. Fantastic pickup, absolutely amazing sound. But then you would expect it in that particular venue because the head of sound went round and listened, and they played different places of microphones to make it the best pickup. And that's, you know, having said that, that's where I wanted someone to put them in the first place. But at least, you know, they actually tried. So it can be done, you know, with a thought. It's also useful sometimes to roll off the low frequency response of the mic, stops picking up traffic noise in particular next to some rooms. Again, you don't notice it maybe when you're sitting there, but my gosh, if you've listened to that over an assistive listening system, it's really offensive at times and needs to be done. Taking the output of the ALS from a sound system can be fun. The nice thing, if you've got a sound system, the chances are you've got a microphone close to whoever's talking. You know, it has to make it work. So actually, it's a good place to actually do that. But there are a few rules and things you need to do. You need to make sure that there's a dedicated output for the assistive listening system, like an aux send. And once the correct level's been set, it doesn't get adjusted. And then the AGC in the ALS should maintain the level, assuming that the ALS actually has an AGC. And the chances are it won't, unless it's a loop, which it will. So, you know, you see levels, and people have, oh, I've turned down the fader, I've done something, no signal to the loop or the assistive listening system. You've got to know about it. So, the other thing is it's sometimes difficult to actually get a feed from the mixer or from a good source. So some people have taken the feed from a loudspeaker line. This is really not a good idea. Because there's going to be maybe EQ on that speaker line and maybe even some delay. That's more rare, but certainly EQ on a line. So you end up with the actual response going into the assistive listening system looking like that, because that's the EQ that was applied to the loudspeaker system. That's really typical for a distributed loudspeaker system. So we've got this great big suck out. I don't mind about the boost up there, that's fine. So not a good idea, but now let's try this one. Again, that's a real measurement of the output of the signal going to the loudspeakers, if you like, if that's where you'd pick up. Totally reasonable to sort the loudspeakers out in the room, totally reasonable. Makes it really work. But you don't want to have that going through your assistive listening system. You know, you want a nice, flat, even response. Roll off the bottom end if you want. Yeah, just think. And in that particular case, they could have picked up the signal quite easily from there was a submixer located not far away. So yeah, but it's ignorance, really. It's bliss, apparently. So let's have a look at latency. If I've got time. In ICTR, we actually state, or it states, sorry, not we, it stated that the latency should be no more than 30 milliseconds. Well, ideally it should be 30 milliseconds or less, maximum 40. So just bear those numbers in mind as we go through this, and I'll build up. Let's have a look at a system. And it doesn't really matter, I'm not having to go at any particular system. So we've got a microphone, a preamp, and then in this case it's Wi-Fi, and we'll do other ones later in a moment, you'll see them. So that's the transmission chain. You then have some sort of receiver, which in this case is a smartphone to pick up the Wi-Fi, and it's then Bluetoothed into the hearing aid, and then eventually into the listener's ear. So it's quite a complex chain of various items. And let's put some latencies onto this and see what happens. So it'll be a digital preamp of some sort, and DSP. You might get 5 to 10 milliseconds delay. In itself, not a problem. The Wi-Fi system, anything between 75 and 500 milliseconds, depending on the Wi-Fi system, and it depends on the network, and it depends on how the traffic on the network. And that's the point, and you don't know what that will do. Nobody can know. So if you test this thing late at night, there's no traffic on the network, it works a treat. Now do it during normal working hours, and you can have 500 milliseconds easily on delay on the network. We then got a delay in the smartphone. Smartphones can be anything between 50 and 200. In fact, I've seen measurements way more than 200, but let's be reasonable for once. Hearing aids themselves, they've got processing in, so you've got, if you're doing really well, if you've got 5, 10 is much more typical for the delay in a hearing aid itself. The new generation of hearing aids coming out are getting closer to 5, but you know, the vast majority out there are 10. And the thing is, these are all cumulative, they all add up. And so at the end of the chain, you've got something between 135 and 500 milliseconds on that chain. So forget the thing that says, oh, our system's 50 milliseconds. Oh, no, it isn't. It cannot possibly be once you actually put it into a system. And you have to think of the end to end, because that's what the listener is listening to. I don't care what your oscilloscope says or your analyzer, be it NTI or whoever's. It's the ear and it's the listener that actually is the important part. So you've got to get this right. And I've never seen these figures published anywhere else. Surprisingly not by the manufacturers. There's a surprise. So let's have a look at another system. This time we're going to use a receiver and a neck loop. And so that's the same delay. Now if you get a receiver that's well done and you don't have the Bluetooth into the hearing aid, you maybe get 10, 20 milliseconds. You've still got the hearing aid delay and latency, so you're now into 95 milliseconds at the best you can do. That's way too much. That's 3 times what the recommendation is. And actually unusable. I mean, it was really interesting when we came in. I was listening, this is infrared. I mean, it doesn't really matter what it is. The delay and the latency on this is unlistenable to almost. You can listen to it, but it's bloody annoying. It's well over 100 milliseconds. I've never seen an infrared system with 100 milliseconds on it before. So it just depends on the processing. And again, I'm not having to go at any particular manufacturer or any particular system, but it can happen. That's what I'm saying. And it's, you know, when as a hearing impaired person, you're struggling for every decibel to get. And you are struggling for every decibel. To start, I was going to say buggering it up, I'll be more polite. To start screwing it up by having this due to ignorance really is quite appalling. So you put a radio mic into the system. Oh, let's see what that does. Because it's the same system. Okay, well, radio mics, maybe they're going to be digital these days, so maybe 5 to 20. Some of the microphones are out there at the moment with 20 milliseconds latency in them. So you go through the sums again, and you end up with 140 odd milliseconds. That is not a viable ALS. It really isn't. Oh, let's look at Auracast, the saviour. So now we've got an Auracast transmission system in there, and it's a bit vague, and we're going to go phone and Bluetooth, because you will need, well, for most things you're going to need that. The idea is that Auracast will go straight into a hearing aid if a hearing aid is equipped with Auracast, and you can get one stream. But if you want anything else, you're going to have to use some other device to do that. So it's the same sort of system, so 5 to 10 DSP and the thing. Auracast says it will be less than 50. Okay, I believe them. I don't have a problem with that. But we've still got to go through some sort of smartphone or some other device to listen to it. And we've still got to go through the hearing aid. So we're still going to end up with quite a delay or a latency in the system of at least, 110 milliseconds or so. Now, it's very vague at the moment as to what Auracast mean by their latency. Do they mean the whole system, or do they mean just this bit? We don't know, so I'm kind of playing it by ear. In this case, let's go, instead of having that, we've got an Auracast receiver, and we've got a neck loop going into our hearing aid. So we've still got the same latencies. Now we can get it down to 10 to 20 maybe, no latency in the neck loop. Still got the hearing aid. So now we're into the 70 to 90, which is a hell of a lot better. It's still not what we want, but it's starting to get better for where we are. And then stick a radio mic in, and of course you're going to add another 5 to 10 milliseconds. I thought we did, yeah, okay. Now, there we are, that's the one you've just seen. Let's compare that to a loop, just for the hell of it. And I'm not pushing loops, I'm not pushing any technology, I'm just making comparisons so that people are aware, because this information is not out there. So let's take a thing. Let's have a digital loop amplifier, so 5 to 10 milliseconds. Let's give it some latency, not unreasonable. Another 5 there. I'm being very, very generous. There's nothing in the AFILs. We've still got 5 to 10 in there. So now we're somewhere between 15 and 25 milliseconds latency. Fine, well under our 30. Totally doable, you know, quite logical. Why are we going from that to this? You know, well, because we can do all sorts of things. We can do multi-streaming, we can do stereo, we can do them. Great. All you want is a decent signal going to your hearing aid at the end of the day. Yeah, if we can improve it and do other things to it in course, absolutely. Let's go for it. But, you know, don't give up what you've already got that works, just for the sake of technology. There's a thing saying, oh, well, you can use hearing phones and... Hearing phones? That's a good one. I've just been, and you thing there, hearing phones. I like that idea. Somebody remind me afterwards, I'll patent it. So we've got headphones and earbuds or whatever. Those are great for the younger generation rather than a hearing aid. The point is that the hearing aid has got the hard of hearing person's prescription in it. And it maybe has 30, 40, 50 dB of gain in it, frequency dependent gain. You can't do that with an iPhone and earbuds and hearing phones. There's a kind of typical requirement, that's a theoretical one. There's a real measurement of a real hearing aid, and look at the gain, it's nearly 30 dB in that. You cannot do that with a smartphone. Let me repeat that, you cannot do that with a smartphone. Only a hearing aid can do that. And that is what the person needs. You know, don't give them a nice thing because it looks nice. Give them something that actually does the job. It's not unrealistic. Okay, so people can start bringing their own devices, certainly if, you know, the various things. That's fine, but it has to be compatible with the system that's there. But you probably won't know until you've actually tried it, and that's one of the biggest problems. So if you bring your own smart device, then you've got to connect it up. Actually, that one may not connect up, but you get the point. So, and also you need competent support to help you. So every theatre that uses this or every other system is going to have somebody on the staff who really understands how to use it and how to connect up iPhones or various types of smartphones to their system. I don't think that's going to happen, but it needs to, because otherwise it ain't going to work. I'm going to whiz past that. Basically, every ALS needs automatic gain control, and it should do something like that, and it's all set out in the standards. End of story. Most of them don't do it, and that's the point. Okay, so, ignorance is bliss. Indeed it is, but it's an impediment to harder hearing. So only hearing loops at the moment have got any standards worth their salt to actually do it. The rest is the Wild West. There's no standards, there's no requirements for any of these other systems. They can do what they like. They can have latencies of 500 milliseconds, and some of them do. That particular one was ripped out within a week because it was useless. And we want to try and avoid that happening. And it's just ignorance. On both the user or the buyer and even the seller. It's both. So let's have a look at the benefits. Let's not do that one. I think this is the nice one. These are 6 situations that have got it happened to be a hearing loop, but it can be any system, it doesn't matter, installed. And this is the intelligibility that was achieved via hearing aid microphone. So these are real word scores done. So this is real stuff, all right? And you can see in these 3, they're okay. These 3, I mean 0%, 2.6% intelligibility. I mean, 2 words in 100 you vaguely understood. Now in fact, that's reverberant and that was noise. So we've got 2 cases each for that. Now what happens if you have an effective assistive listening system? Wow! Now we can get 80–90% intelligibility by having the microphone close to the person talking, not picking up the noise, but actually doing the decent job. That is a phenomenal improvement, and that's what you need. In fact, it's interesting that in this case it actually got slightly worse, but that's choice of microphone and bad microphone things. But the rest of them picked up quite nicely. Huge improvements. So it's there, it's doable. We know about it. The thing is, when people turn up, they need to know there's an assistive listening system at the venue, but they need to know what type it is, so they can know what to expect. Not unreasonable. And they also need to know if it's working or not. How many? Literally, the reason I go round with a thing and I go to the theatre is I take the thing to see if the system's working or not, and how good it is or how bad it is. And sometimes I'm really pleasantly surprised, and other times, what do you expect? It's a assistive listening system. So we need to know if it's working or not. That means having a testing regime or some sort of signage to do that. So we've got a lot of education to get through and do this. For example, a venue on their website should tell you what system they've got. Very easy to do, but very, very few do it. I don't know what it is in the UK, but the hearing impaired don't want to make a fuss. I mean, we don't want to make a fuss anyway, but they're even less inclined to make a fuss or actually get action. And yet they need to. Because to be fair, if you don't tell people, they don't know. Ignorance is bliss. So let's have a look at some of the types. How can it be accessed? In other words, which devices can you use? Can you use my smartphone? Can I use my hearing aid directly? Do I need some sort of receiver? What equipment can I borrow from the theatre or the venue or whatever? Do you have receivers, etc.? Where do I get it from? I mean, that's such a basic question, but I've seen people wandering around venues trying to find out where to pick up their receiver from. Is there a system to show that it's actually working? So once you've got it and you've coupled it into your hearing aid or whatever you're doing, does it actually work? Oh, no, you have to go into the auditorium and do that. Yeah, but it's not on yet because it only starts when the show starts. Oh, so you're in the middle of a row and you don't know if your hearing aids, your assistive listening system is working, and you've got to make up the decision, do I now try and start up and disturb the rest of the row? Will I try and get this fixed? Who do I go and talk to? Come on, this is not a service that we should be doing. We also need to know, is everywhere covered? Because in fact, often cases, not everywhere is covered. Only certain areas end up being covered for various good reasons. I mean, I can remember I did a place that the stalls were covered because to do to the balconies was incredibly complicated and very expensive. And when you looked at it, you go, okay, look, we've done 800 seats in the stalls, that's not unreasonable. To do these other ones, we just tell you that's where it is. So we should have information so before you go you can find out what goes on and then who to contact. I mean, these are really basic things, but nobody does it, and they should. You can get signs that illuminate when, this in particular case for a loop, when it's on and working. Doesn't mean to say it's working well and it's intelligible, but it says it actually isn't on and working. I would rather you bought a loop lister and walked around and actually checked the thing was there and had a regime for doing that and people know it. But in fact, it is in one of these standards that you should have a permanent monitor. It's hidden away in the small print, I have to say, but it's there. Matching of levels, this is going to be an interesting and confusing area, I predict. The point is with a hearing aid, you set them up, and the standard for a hearing aid is 70 dB SPL. It doesn't really matter in speech, and that is where you actually, that's the reference level. So if you're doing a telecoil in a hearing aid, you set it up with 70 dB going in, or you set it up with a magnetic field of 100 milliamps that produces 70 dB. They're the equivalent. So the two are the same. So when you switch from your normal hearing aid to your T-coil, the level doesn't change. They have to be balanced, and that's the point of doing that. Don't do that one. Auracast started off at minus 25 dB. They're now talking about minus 35 because of other applications they can see where they might want to do that. Okay, that's no problem as long as you just set that up. That's not a problem. But we've got to now, most systems, you take the average level and then you put some headroom on and see what's going on. Loops look at the maximum level and then work backwards, which is a very strange way of doing things. Somebody once tried to explain to me why you do that, and I never really got it, and they didn't get it either. There's probably good reasons. And if you look at this, there is a graph of 30 seconds worth of real speech with some gaps and pauses. I just happen to have set it up at 70 dB to make life interesting and easier. And that is, if you like, on the right-hand side is the 100 milliamp thing. There is the 0 dB that you set up for hearing loops. Except the idea is you shouldn't set it up to that. That will be the occasional peak level. Most people actually want to make sure it's getting at 0 dB, so they turn it up. I have measured lots of samples of speech, and I have never yet got one that ever got, once it was set at 70 dB, up to the reference level. 2 or 3 dB, yeah, but that's a hell of a lot. Whatever. But anyway, it gives you an idea of where we go with the thing. But why aren't we just using the 70 dB? Because that's what we're going to have to do with Auracast when it comes over. We're going to be looking at a long-term level. Okay, so we can have lots of standards and lots of technical guidance for loops, intelligibility. We should have 0.7 STI as a minimum for an ALS. Latency should be less than 40. I'm going to bypass the noise because that's not really understood. So obviously we need a guide and some guidance as to what ALSs should do, these numbers I've just been talking about. Oh, there's a surprise. The ISCVE have in fact produced, or are producing I should say, a guide that goes through most of what I've just been talking about. Not in the same way, but actually has most of that information in it. That's going to be available shortly, whatever that means. I'm getting a nod from the back, but anyway, it'll be there. And it summarizes basically all the ALS types and their applications, where they should be used, where they shouldn't be used, and some of the issues and bits and pieces. And there's a big chunk on microphones and how not to use them. There's also a table of applications and use for the thing. But we also need a code of practice, not just a guide. And so to do that is quite complex. And so over the last 6-8 months, there's been a team of some industry experts putting together a code of practice for all assistive listening systems. It's technology agnostic. It doesn't matter which technology it is because we're just using the science behind it. This in due course will be distributed by ISCVE, I hope. And in fact, it will look remarkably like that. It's still being written. It's going under a very rigorous peer review process at the moment, which is taking quite a long time. and it keeps on being added to almost every day. It's 55 pages at the moment, and it's going to get bigger. So it's quite a read, I mean, it's a good bedtime reading for getting to sleep. But anyway, it will be available hopefully by the end of the year, if not first thing next year, depending how it goes. But the thing is, we need an authoritative standard. We need something from BSI or IEC to actually have any clout. And I've spent the last year trying to convince IEC that they need a standard on this. IEC it's like a mountain, moving it very slowly, or like a glacier, maybe might be more appropriate. It does move, but slowly. Eventually, we've got somewhere. And in September, I got the go-ahead to actually start producing a code of practice and a standard for assistive listening systems that will become an IEC document. It's going to take quite a while. It's going to take 2 to 3 years to do that. I'm hoping it'll be closer to 2 than 3, but it has to go through a complex process. It has to be voted on by every country that's involved with the IEC at least 3 stages. And they take 3 months per stage. So then there's a year gone, So yeah, it's going to be a hard slug, but hopefully we'll get there. I'm finishing up. Right, the future. Will Auracast take over from loops with things? In the long term, I think it probably will. It's got the potential. It's got some rather nice features in it as well, which will augment assistive listening systems, as long as it's implemented correctly. And that's where we've got to make sure that that happens. But loops are going to be around for at least 10 years. No question about that. In fact, for a while, well, I'd say there are no Auracast systems. It's going to be years before you start actually installing them and having equipment available to do that. So for the next few years, there's no obsession. I was asked 2 weeks ago by a church what they should do, and I'm going to put a loop in. There's actually no problem with doing that at all. That's the best thing you can do. And we can have, Auracast can be added to a loop so that the two can transition. I'm not sure if we call it a bloop, but whatever, whatever it might be. As long as it's not a blooper, that's the main thing. And then you can also use a neck loop with an Auracast. So if a place goes to Auracast, you can still use a hearing aid. So there's no obsolescence built in. So it should be good. It's going to take years to figure out some of the applications and implications for Auracast to make them work properly. But the point is, imagine you're walking in a shopping mall somewhere, you get the emergency broadcast straight to your hearing aid or whatever. What you don't want is the bloody adverts going straight to your hearing aid, but that's a whole different issue. But let's get the emergency announcements straight into your hearing aid. And in fact, there's provision in BS 5839, the latest version, and in 7827, which came now 4 years ago now, it's already in there that there is provision for that. I must have had a crystal ball at the time. But I asked the question, should we not be thinking more about the users and their requirements rather than the technology? Just because we can do something doesn't mean to say we should, unless there's a really good reason for doing it for the end user. At the end of the day, the assistive listening user just wants to be able to hear an intelligible sound easily. That's all they need. We don't need stereo for that. But it'd be nice to have some other things. And again, I think, why is it the hard of hearing? Only 22% of them being told about loops and other accessories that they could use with their hearing aids. They really are getting a bad deal. And I say few people understand that they only work over 2 meters or so, and that you'll partially get hearing restored, and it really is partial. There's also a widespread impression that the assistive listening system and loops in particular, because they're more popular, don't work and they're generally not fit for purpose. The thing came out last week. But if you read the hype, Auracast is magically going to fix that. You just wave your magic Auracast wand and everything will be fine. Just need fairy Auracast to turn up, and there we are. But remember, rubbish in is rubbish out. It may be really high fidelity rubbish now coming out of an Auracast loop, but it's still rubbish, I'd be quite happy as long as it was not quite so good fidelity, but it was intelligible. That's what we need to do. Okay, that's it. Enough of the lecturing.
Thank you, Peter. Thanks very much, Peter. Yeah, I think we can all easily agree that if you actually haven't got your microphone placement considered, then whatever technology you use to move it to the hearing device is totally pointless. So, yes, first the hand up. Here we go.
Thanks very much. Hi. Can I start off with an unknown quantity, Peter, that you haven't explored in your presentation? And this is going back to the ignorance is bliss. Just going back to the different technologies used, wireless technologies, which all make use of electromagnetic radiation, right? Loop system, inductance, infrared, obviously the infrared spectrum, and then we have all the wireless technologies out there that make use of the wireless spectrum. What I want to talk about is something called RF saturation, because all these different technologies, whether they're Bluetooth or Wi-Fi, all use the 2.4 gigahertz band. Now that band isn't a massive band, and there's a lot of congestion in that band. If you just take just an average meeting room, you know, you've got wireless sharing, you've got CCTV, you've got intruder alarm systems, you've got people there bring your own devices. There's a lot of 2.4 gig saturation in that room. I did a presentation several years ago for Rose where we were looking at the difference between infrared and 2.4 gig systems. There just hasn't been enough research done within the RF saturation field when looking at all these Bluetooth systems. And it's okay if you're transmitting data because you can afford to drop a packet here and there. If it's audio, you absolutely cannot afford to drop a word. So I think when you're looking at Bluetooth systems, I think you have to think about this issue with RF saturation. And I think this needs to be part of those standards as well. I think there are a lot of people probably in this room that are very ignorant about RF and how the 2.4 gig band works. I think it's something that all these audio over Bluetooth systems, audio over Wi-Fi systems really need to take into account when they're thinking about, you know, developing their technologies.
Absolutely, I couldn't agree more. I mean, okay, you can say that Bluetooth LE will frequency hop and do things, but there is still the overall saturation, and it's all within that band, as you say. And again, you might test a venue when it's nice and quiet, you know, what's it like under real RF conditions?
That's right. And remember, 2.4 gig is the same frequency that you use to cook your food in a microwave. So when you've got bags of water in the room, the more people that are in the room, the more that radio energy is going to get absorbed, right? But I absolutely feel very strongly that this should be considered within the standards. Some research should go in.
Absolutely.
When that standard is
and it's the same frequency as the cat flap as well. You know,
yeah,
so,
absolutely.
Get that, you know. So, but no, it is, and that's part of the Auracast thing, and that's why it's going to take a little while to come out, I think, because they need to do the research.
Yeah, but it needs to be part of this standard as well.
Absolutely. Well.
And of course, everybody's using 2.4 gig because 2.4 gig is license free. But when you look at the frequency allocation, 2.4 gig, we're still secondary users. The military are still primary users for 2.4 gig.
Right.
So that's the other thing to
consider. But they'll be over here
well.
Yeah. It's a really good point, and something that needs to be. I mean, the trouble is that there are very few people. If you're an audio engineer or you're an RF guy, you know, and the two kind of sometimes merge. Excellent. I mean, you're right. You're lumbered already, I'll tell you. But yes, no, thank you very much, because we really do need to look into that. And there's a lot of things. The only good thing, if you like, with the Auracast or the BTLE thing, it's got a much longer range as well. So they're talking of 50 meters, so it's 10 milliwatts output. It is indeed. So it depends what else is going on, and you're absolutely right. So in some applications, it's not going to affect it. You know, you stick a church out in the middle of the country somewhere, you've got no problems at all. Now stick it in an office block like this, and you want to do something, yeah, absolutely. Yeah, absolutely. No, good point.
Anything else from the room? We did have a comment from on. Okay. We did have one online comment from actually from John Woodgate.
That's a surprise.
Just actually really pointing out that 2 hearing aids is a considerable improvement on 1, and you can get that within the NHS guidelines. But
That's true, and then they can start talking to each other again, which is an advantage of Bluetooth LE. So then you can actually start to get true binaural hearing rather than some weird thing. So yeah, no, I mean I'm not saying there are some advantages. Absolutely, there are, and that's a really good point. So I think if those can get starting to be used, then that would be really useful. But yeah, absolutely.
okay, anything? Gordon wants to go last. Anything else before we pass the microphone to Gordon? No? Okay, in which case, Gordon?
I'm only short and sweet. You have just been told right at the beginning that ignorance is bliss. And boy, have I been on the receiving end of that. And so now, as from today, knowledge brings responsibility. Every one of you are going to feel guilty if you don't get it right. Sadly, I just had to listen to the infrared. The latency blew me out the water. But it was so-called tested. It's okay. But it wasn't. So you all know about it now. Knowledge brings responsibility. Well done, Peter. Congratulations.
Okay, so for the third of our presentations, we are welcoming Greg from Midwich, who is going to give us a surviving the death of the high street, which hopefully is slightly over-egging it. We're not going to kill it entirely, but the main point is we need to adapt to the changing circumstances ahead of us. So, and without further ado, I'm Greg.
Thank you very much, and thank you, Roz, for inviting me down today. It sounds very fancy. It's just about signage, okay? So, bear with that. Yeah, we're going to be looking today about at sort of high street, everything retail, current trends in retail itself, emerging trends that we're expecting over the next few years, and the display technologies to look out for. So, how the AV industry is reacting to that, okay? And then at the end, I've got some standout installs to show you so you can go, wow, how much did that cost? You don't want to know. So who am I? My name is Greg, and I grew up here in Portsmouth. Anyone from Portsmouth here? Let me sum it up. You are, yeah? Isle of Wight, okay, yeah. Well, that's the better side of the channel, isn't it? Well, so I'll sum it up in a story. This is Spinnaker Tower, and they wanted to create something for the millennium. They wanted to have something ready in Portsmouth for the year 2000, so they got all the funding together to create Spinnaker Tower for 2000. They opened that in 2005, so that's the sort of county it is. So I left. I thought, okay, Hampshire's not the place for me. I'll go to London. I went to the University of Westminster. Any alumni here? I would keep that quiet as well. If I was asked, I would lie. And after that, I moved to Brazil for a number of years. And this is Marseille. Look at this beautiful city. I lived there. And I sat one day on a beach, sun radiating down on me, caipirinha in hand, got these beautiful people, this pretty accent around me, and I thought, this is not the life for me. Take me to Norfolk. And that's where I live now. I work at a company called Midwich. Okay, we've got a few people in from Midwich as well. Good to see you. Yeah, we're based in Norfolk. We're an AV distributor. We have got, well, everything you'd ever want. We've got LG, Philips, Samsung, and of course we've got Shure. So thank you to Shure for having us today. So I thought we'd start off with a quick history to set the scene of retail. If, you know, for nothing else, at least you're going to win your next pub quiz after this, okay? I wanted to just do retail, but I couldn't do it without marketing. It's so linked into what we're going to be talking about in about 5 minutes. So we're going to try and whiz through about 5,000 years of history in 2 minutes. This is where I want us to start, 3,200 BC, okay? Now, we've always had trade. People have always swapped things for other things. But in Mesopotamia, they came up with the idea that maybe we should actually keep track of what we're doing there. So the first known records are from Mesopotamia, 3,200 BC. And we still do that today, don't we? We still keep track of everything we've bought and sold, who's done what. They came up with that idea, commerce boomed. And then in 1500 BC, we've got this. This is the precursor to a logo. It's a maker's mark. Again, this is from Mesopotamia. So beforehand, you just buy something from someone and assume it was good quality. Now makers could add their own mark to something. So you always could trust that if it had the maker's mark on it, it was good quality, and we still use that today, don't we? With this sort of thing. You know exactly what you're going to get. Okay? We're going to jump forward to 800 BC, and we've got markets emerging in the ancient Agora, in Athens. So we've got everything we're going to need to buy in the week that we can get in one day, because it's all in the same place. To us, that sounds pretty antiquated, but that's a massive step forward, isn't it? 200 years later, we've got this. And I think this is probably the single most important innovation on this list. This is the Lydian Slater, which is the first standardized currency. So beforehand, you'd need everything you wanted to trade that day for the things you're going to trade, or you would trust the person wouldn't screw you over. Well, now we can agree what something is worth, and we've got a standardized currency, and it took off, of course. Moving on to 200 BC, we've got the abacus, helping with accounting. People are becoming more accurate with their accounts. And then, in my very, very one-sided view of history, we're going to jump forward about 1,500 years to the printing press. Suddenly, we can get messaging out to the world much, much more quickly than we could before. With that, we had the birth of things like magazines. The word magazine comes from Arabic meaning storehouse, and that allowed us to have lots of different information given to someone in something very compact, including advertising. And this really took off. We've got billboards in the 1850s. Now, you're not just getting advertising in your printed media, but in your day-to-day life. So you're walking down the street, and it's telling you to buy products. Now, with that, advertising in the 1800s looked a bit like this, okay? That's not really selling you the product nowadays, is it? At the time, the idea was, this is what the product does, and the benefit of buying the product outweighs the cost of said product. Keep that in mind. We're going to jump back to that in about 30 seconds. The next thing that happened in 1883 is this. It's called Ritty's Incorruptible Cashier. It's the first time, yeah, it's a great name, isn't it? It's the first time that we had sort of automatic tills. What I like about this is it had a little bell on it, and we still use the language that this created, which is I'm going to ring you up. That comes from this, because when you'd finish it, it would ring a bell. And in the 1890s, we have the first department stores showing up. We've got Selfridges here at the turn of the 20th century. We've got everything you need in one building now, not just in one market, and we're changing retail from something which is a necessity to a form of entertainment. You go there for the day, don't you? Well, maybe not anymore, but it used to be the way. Okay. In 1922, we have the very first radio advert. It was AT&T. For those of you that don't speak American, that's like BT here, okay? The American version of telecoms. And they paid $100 for a 10-minute spot on a radio show. That's 1922, okay? 8 years later, in 1930, 90% of all radio stations had adverts. So they could see what was going on. They could see that it was worth investing in that. So this is how advertising changed. Now remember, we just looked at the soap advert. It told you what you were buying, and that's all it did. Do we know who this man is? Freud. It's Freud. Sigmund Freud, psychoanalyst, and he was very interested in the subconscious. He had a nephew. Does anyone know what this man is called? He's called Edward Bernays. He was Freud's nephew. He was into marketing, and he wanted to use his uncle's ideas to try to sell things to people. So rather than selling it directly, saying you're buying this product because of this, he was trying to sell you a lifestyle. He tried to sell you, well, he was trying to sell things for your subconscious rather than your logical mind. So a couple of campaigns that he came up with, he started women smoking. So, you know, he's a great guy, really, isn't he? But because it was a masculine thing before, and he, I think the phrase he used was some sticks of liberation or something. He was like, okay, if you smoke, you're going to be an independent woman. He also helped the CIA overthrow the Guatemalan president. So again, he's doing great things there. And he turned this into America's signature breakfast. He turned it into bacon and eggs. So that's Edward Bernays. And if you are, I think it's fascinating. There's a great documentary called The Century of the Self, if you're interested in this. It's only 3 hours long, so I'll check that out, okay? So he had these ideas, and they caught on very quickly. This is what advertising looked like in the 1800s. Tells you what you're buying, okay? You're buying soap. He changed it to this. No longer are you just buying soap, you're buying sexual desire. He changed soap across the board. We've got pairs. It's telling you what you're doing. And again, it's now changed to something you can have, something you can be, selling you a lifestyle, okay? Bear that in mind, because we still have that today, don't we? We still have that with Nike. with Apple, it's selling you sort of things that we think are culturally quite good. Just do it, be proactive, think different, be better. Yeah, that still happens, but it's very broad, isn't it? This goes out to everyone. In 1929, we've got the very first supermarket, which was Tesco. And then we've got the first TV advert in 1941, which only cost $8, which is that's a bargain, isn't it? I'd pay for that. Advertising, by the way, again, we're trying to reach as many people as we possibly can well, until recently. So we're looking at one-size-fits-all family-friendly adverts. In 1946, we have 7-Eleven. I know it's very American, but it's a great example of it because, do you know why it's called 7-Eleven? Exactly. When it launched, it had these extended hours. So no longer were you restricted to only shop during daytime hours. You go at night, you go early in the morning. It gives you more time to spend money, and people spent more money. And in 1950, we've got the first shopping centre, which is Northgate Shopping Centre here in Seattle. It's taking the idea of the department store and just amplifying it, making it much bigger. It's a full day out now, isn't it, of spending money. In 1958, we've got the first credit card. Doesn't look too high tech, but it's a great idea. It makes things very easy. You can spend money you don't even have on a whim. And then they added the magnetic strip in 1960s, even easier. You don't need to think. You can just swipe it. Think of all the things you tap for now that you don't need. And along with that, we had the electric till first coming up in the 1960s. So no longer did they ring you up, they started to beep you up. In 1974, the very first barcode, which was for Wrigley's Juicy Fruit. And this is the very first thing that was ordered online in 1994, which was a mushroom and pepperoni pizza with extra cheese from Pizza Hut. They were. I wouldn't be surprised. And then 1995, we have the giant that is Amazon launched, and that's it. That's the end of retail. Done, isn't it? Everyone's online. We might as well close up shops. Or is it? Is the rest history? Some very quick figures for you. In 2022, online sales accounted for 26.5% of retail sales. That's way lower than you would expect, right? After the pandemic, everything went online. Everyone is online. But it was only 26.5. That means 73.5 is still going in store. And I wonder, do physical shops influence online sales? So is it still worth having a shop? Can you go in and influence what I'm going to go home and buy later online? So, what we're going to look at today, we've got some new trends to look out for. We've got 15-minute cities, we've got hybrid working, we've got space optimization and customer experience, and finally sustainability. Going to go get through these as quickly as possible because I know you're all waiting for lunch in about 25 minutes. So, 15-minute cities, we've all heard of this concept, yes? No groans, so maybe people haven't yet. This is the sort of thing that is going to finally give Jeremy Clarkson that heart attack. They want to get rid of cars, is the idea. Or that's how it's sort of promoted in the media. It's not quite that. A 15-minute city is just promoting walking and cycling, cleaner air, and community spirit more than anything. So what we need in our 15-minute city, within a 15-minute walk or cycle, we need green spaces, a supermarket, maybe a gym, definitely a school, hospitals, doctors, shops, and this is a sort of representation of it. What might they look like? It's this sort of thing. And you'll notice very pedestrianised, right? We don't have any cars in that. And the idea is it's green and local, okay? So where are we seeing this happening already? Paris. The mayor wants to lose 72% of parking spaces by 2030. And they also want to cover the city in vegetation, taking up 50% of all space of Paris. That's a big pledge, but they're really pushing for it. They want less cars in the city. They want people walking more. They want people staying in their neighbourhoods more. Not because they want to control anything, which is sort of, I know that's how the press sometimes like to portray it. It's just more about that hyper-locality, about sense of community that we have lost, haven't we? In Barcelona, we've got the idea of a super block. Has anyone been to Barcelona? Seen these? So they're combining them now. So rather than just one block, it's not quite a neighbourhood, but it's bigger. We're combining a few of those and again, pedestrianising them. So you've got everything in one space that you can walk to, or in this case, it would be walking, but in a bigger space, it might be cycling as well. Again, greener, more local. And this is an idea from Denmark, the Danes in Copenhagen, they're building a sort of monorail railway system around this, the city in the hopes that they can reduce traffic, but also on the top of that, oh well, I say on the top, on the bottom of that, they've got a covered cycle lane following it all the way around, again doubling on their investment there. So it is happening across the globe. And I wanted to have a look at this. Anyone been to Stoke Newington? No? I used to live there, and I was thinking, you know, when I was reading all this, and 15-minute cities isn't a new idea, but when I was reading about them, I thought, well, we're nearly there with Stoke Newington. We're really close, okay? You can see on this map here, this is all within about a mile of where I used to live, near here, Rectory Road. We've got everything we need. Look at all the green spaces. The only issue we've got is that big yellow line going down the middle there, which is Kingsland Road. But we're not far off being a 15-minute city, so it's really not a big jump for us in the UK, especially in London, because we've got so much sort of going on and piled on top of each other in the city. So, how are retailers reacting? Well, we've already used that word a few times, local. Everything's hyper-local now, and that allows us to have bespoke messaging, because when you're local in a community, you tend to have shared ideas, you tend to be a similar demographic, don't you, if you're in a small community, and suddenly messaging can change. So it doesn't have to be these broad, sweeping messages that we had before. Remember that advert from the 1940s? It's got to appeal to everyone in America. We only need to appeal to people within 15 minutes because they're the people we're trying to sell our products to, okay? This builds stronger communities. We can have real-time promotions because if we're only focusing on one community, we don't need things that are going to be attractive to everyone in the country, do we? We only need things that are attractive to people in that particular community. And we can be updating our signage all the time with things like new arrivals and limited time offers. The technology that shops are investing in at the moment for this, first of all, is high bright screens for window displays. Now these used to be extremely expensive, but with the rise of LED technology, LCD is dropping in price dramatically. So these are becoming very affordable for even small retailers. They can afford to have these in their windows. The idea being that they are bright enough to combat the sun, so you have them behind glass and you can still see them. As you can see, we've got direct sunlight, but the image is still clear. The other thing people are investing in is these IR-rated screens. So these are screens that are okay to be used outdoors. Again, they used to be extremely expensive, not so much anymore. People can afford them. This one is built into a kiosk. I've used that one because that's local to us where our office is. I was mentioning this to the product manager for Samsung, and he was like, please, can you go to Tesco and get a picture of my product in there? So I did it for him. There you go. But they are sort of weatherproof. The idea is that you can have them running all day, every day. They're not damaged by the elements. And so you can be messaging to people at all times. So the next thing we're going to look at is hybrid working and weekday shopping. People, now that they're working at home, part of the week or maybe full time, they've got their lunch break where they can go out and do things, haven't they? They've got that commute time they used to have in the morning that they've freed up. For some people, that could be hours. So we've got people on the high streets again during the week. It's something to do. It's a form of entertainment, isn't it? And that means we've got a movement away from the reliance on retail parks. So you don't have to go to a retail park and do everything on a Sunday afternoon, do you? You can do it bit by bit during the week. And we don't need online retail as much if we're using it as a form of entertainment during the week. So with this in mind, with people going to shops more, this is sort of the real benefit of online, isn't it, for retailers, that they can track what you're doing. So you know you're on Google, and every website you visit, it pops up with accept cookies, and if you've left your tinfoil hat at home, you're like, go, yes, I'll take it. It's tracking what you do. It knows exactly everything you're clicking on. It thinks it knows who you are. And so you end up with these sort of offers coming through on your email. You get these all day, every day, yeah? If you ever open up the promotions tab in Google Mail, on it, you'll be surprised. You get about 1 million a day. And then we've got this that comes up in search engines. So you've got the sidebars where it's things you've clicked on before. That's not my search history. But it's super easy for them to do it, isn't it? Because they can track everything you're doing on your phone. They can't track your thoughts. So how could we do that in the real world? How could we track you in the real world? And this is some real tinfoil hat stuff now. Geofencing. Anyone heard of this? Yeah? Okay. especially if you've got an app from a retailer, they can track where you are if you've opted in for GPS settings. Now, there are issues with GDPR, of course, which are being curtailed at the moment. They've got away with it with, you know, you're opting in. Do you know what you're opting into? You're probably being tracked, okay? Geofencing, for those that don't know, they set up an area, a GPS area, or possibly it's linked to Wi-Fi within a radius of your shop, or possibly only within the shop, okay? And that allows them to know that you're near. What Burger King did very cleverly with this, they had a promotion called the Whopper Detour promotion, and every time someone came within, I'm not sure how close it was, but let's say a mile of Burger King, they got a notification pop up on their phone that said, oh, a Whopper, you can have it for X amount, super cheap. They got 20 times more engagement from that than any other promotion they've ever run, which is ridiculous, isn't it? That's how it works, because they know you're so close, and it's convenient, isn't it? Oh, I can just pop over there, it's come up. This is really taking off. We'll get onto one that I use sort of every day without even thinking in a second. But this is what I think might happen in the coming years, is they can track where you are. We're going into shops more as a form of entertainment now, and we've got signage in shops that are selling things. Again, they're quite broad messages, aren't they? If they know I'm in the shop, and they know sort of what I've done previously on the internet, what I've looked at, what sort of things I'm interested in, and with signage management systems at the moment like Wave, where we can update at the click of a button, it could automatically read that information, have a list of products ready to go, and suddenly the products change on the signage, couldn't it? There's not a lot standing in the way of that happening. It hasn't happened yet, and this is just speculation, but I'm sure this is the sort of thing we're going to see. Because what they want to do is they want to advertise to you, not to the general populace. They want to make a sale, don't they? They want you to feel like they're calling you on the phone. I don't think we're far away from that. And one place that it does happen where I go every day, anyone shop at Sainsbury's? Yeah? Good. Smart Shop, so it's on my phone. It's tracking everything I do. I go in, I log in. The reason I use this as well is because there's always, I don't understand it, there's always a queue for the checkout. So there's always about 100 people queuing there. And no one's using this, so of course I'm going to use that. But it's tracking everything I do. So I walk into the shop and bang, oh, you can have this for this price today. Of course I'm going to buy that. And it works really well, doesn't it? And then I go here, and how do I check out? I scan that, tap my phone, and I'm gone. We've got it happening in McDonald's again. I've talked a lot about McDonald's. We'll be stopping at Liverpool Street on the way home. Again, it's super quick, isn't it? But you log in, don't you? Have you all got the McDonald's app? It sort of forces you to get it. I mean, how good is that app? I was running late to work one day, and I thought I'd try and get away with it by calling my boss and saying, I've hit some traffic, but I'm going past McDonald's. Do you want anything? And he asked the entire company, and I ended up spending about £100 there. But I'm still living off the points. I haven't paid for McDonald's in about a year. That's how they do it, right? So what technology are we seeing here? Obviously with the signage, nothing new. LCD screens are still the dominant screens that people are buying because they're so affordable now. They're so affordable. And LED is taking over. We'll talk about that in a second with a different sort of install. And then we've got the touch screens. They're predominantly PCAP touch screens. For those that don't know the sort of different types, the two most popular are IR, infrared, which is the sort of thing you get in a classroom, in a conference room, which looks just like this. It looks like a signage screen or a TV, and it's got an infrared sort of matrix that goes across, and it measures where you are by finding out where the disruption is. PCAP is just like in your phone. So that feels like paper. Your phone obviously feels like glass, doesn't it? And that's what a PCAP touchscreen does. And just like the LCD screens, they're becoming more and more affordable. So more and more retailers are using them as sort of self-service things. They've had them in Argos for years, haven't they, where you can go through, they got rid of the catalogue. You know, imagine the savings they've made now, because that catalogue, you know, you used to pick up one a week, didn't you? And then, well, yeah, throw it away. Okay, the next thing we're going to look at is customer service and space optimization. So online shopping, it is growing, but remember, we're only at 25% at the moment. What are we going to do with our shops? If there are shops that have shut down, aren't there? Like Top Shop, I know Top Man, Top Shop's gone as well, hasn't it? Over to ASOS, because they don't see the point in having a shop. I disagree. If we can create a unique physical retail experience, that's how we're selling. It's marketing. We want immersive interactive encounters, so not just you know, touching the screen at the end to check yourself out, but actually intuitive and like clever, fun things that make the retail experience entertaining, because that's what gets people into shops. Memorable experiences links into the first one, and cross-selling through digital signage. That links into what I'm thinking is going to happen with geofencing. I'm there to buy something. They know I want that jumper. Why not put an image of the jumper with the trousers that go with it? Okay. So we've got some. This is where we've got like the cool installs. So first of all, we're getting loads of different sizes of screens coming out. So this is like a 37-inch, but it's 26 by 9, I think. It's a ridiculous ratio, but that's because we can put it anywhere. We can fit it up above there. So you've got signage everywhere in your shop. It's constantly promoting products to you. Okay, and then we've got the LED install here at Superdry. Anyone familiar with LED? How it works? Sort of the modular system, yeah. So just very quickly, LED literally means the LEDs. You know, the little diodes you get in anything electronic to tell you it's turned on. But we've got thousands and thousands of them in a module, and they come in modules about this size, and you can create sort of any shape as long as it's made out of squares. Okay, as long as you've got the processor to do it, you can do what we've got Superdry doing here, which is create an arch around it. This one's from an airport, I can't remember which one, but if you go to Stansted, I think I was at recently, they've got it on loads of the stuff there. They've just got all this signage everywhere, and it makes you want to buy things. And in that sort of environment, you've got nothing else to do, have you? So we've got this sort of thing happening, and then we've got the sort of even more out there technology. So we've got transparent LED here. This is from Oxford Street. This is quite a new install, Foot Asylum. So you've got signage in the windows. There's still windows. They're still letting light in. But look at how amazing that looks. And that's updating. That's giving new content all the time. The way they do this, it's not too complicated. The LEDs just have a bigger pixel pitch, and they're on a transparent layer when they're installed. So if you got up really close, it wouldn't be truly transparent. But from here, it looks great, doesn't it? And then we've got over here OLED. Anyone got an OLED TV? Yeah? Any issues with it? What's the issue? It failed. OLED, yeah. I'm not surprised. OLED is getting better and better and better, though. So the biggest issue historically with OLED was screen burn, because it's very susceptible to that. So you still shouldn't have images that are static, and that can be an issue. That can be an issue for signage, can't it? Because often we want to show one image all day. Menu boards, for example, you don't want to change it too much. You can't really have static images, but it's getting much, much better. We're not far away from it being as good as LCD in that respect. Where it is better is it's super thin. So this is the biggest OLED install in the world, I believe, which is in Dubai in their shopping centre above an aquarium. Because it's so thin, it can be bent to any shape, well, within reason. Okay, it's not going to be a cylinder that big, but it can create these amazing effects. It looks amazing as well, because the contrast ratio is in effect infinite. There's no bleed between the pixels. So this is the sort of thing that we're seeing more and more. You see it on Oxford Street, right? When you walk down, like every shop has got these amazing installs, because they're using it as a showroom. They're using it for marketing as opposed to just making sales there and then. Here's one from the Samsung building in King's Cross. Again, this is LED, and they've used enough panels to create this sort of curved effect. And if we're looking for something a little more cost effective, we're still seeing projection being used in retail. This is from Gymshark in Oxford Street. So we've got a projector there. It's old technology, isn't it, projection, but it's still used. It's still used because it's so cost effective. So the technology we've seen there, in projection, cost effective, we know how it works, and it's scalable as well. So if you need a huge amount of imaging, you can still use a projector, and it's going to be much more affordable than LED or OLED. But of course, it can't be used in things like direct sunlight. Modular LED, which is the one we talked about, where we can create shapes out of the tiles. We've got transparent LED, which is like we had with the bigger pixel pitch, and then OLED, which, does anyone know what OLED stands for? Organic. Why is it organic? Is there like a little fish in there that? Yeah, exactly, yeah. No, organic just means it's a carbon-based technology, okay? So I've broken it down for you there. I'm sure that makes perfect sense. How long have we got? We're doing well. Sustainability is the last thing we're going to look at, okay? So you've probably heard this for the last 20 plus years, right? Everyone's moving towards being more sustainable. It's so important for their brand image. A report by Capgemini, I've said that wrong, found that 77% of consumers are more likely to buy from and remain loyal to brands with a socially responsible pledge. So you want to appear like you are green, yeah? That's going to sell more of your product to someone. And there is cost saving involved in that as well, because when we think of green, we think of less energy, less packaging. So the first thing I wanted to quickly look at was, according to the OC&C, these are the top 10 brands in the UK that customers see as green or sustainable. And I've taken this, I just picked one at random. First thing I found on the Body Shop website was this: our focus is on using fewer plastic materials where possible, etc. They're really, really hammering this home, okay? And that's across the board in retail. People, no one's there sort of championing like, we pumped millions and millions of kilos of carbon into the atmosphere last year. Like, no one's doing that. Everyone's trying to appear as green as possible, okay? So is the AV industry. So this is from Samsung, this is from Philips. Straight away on their landing pages, they want you to know that they're green. How are they doing this though? How can a technology that uses watts and watts of electricity all day, every day be sustainable? Well, first of all, we've got packaging, okay? Packaging is the easiest thing to do. Let's use less packaging. How can we make something still safe to ship in, but using less? It's not too difficult. We used to use way too much polyester and things like that. They're not printing on boxes anymore, just very basic information, because the box isn't selling it. You're not going into a shop and looking at it and buying it from the box. You buy it because you see the item there. So that's the first thing they're doing. The next thing they're doing is power consumption. So remember these high bright screens that we have in the window of shops? They're pumping out thousands of nits of brightness, and that's expensive. That uses a lot of electricity. But they don't need to do that all the time, do they? What if a cloud comes over? Suddenly they're brighter than the sun. You don't need that. So we have on them a device that will react to that. It's a light sensor that can go anywhere on it or anywhere you like. Plugs into it and it will find out when brightness has gone down, ambient brightness is lower, and it can lower the brightness of the screen. And that's going to save, for an install like this could save hundreds of pounds a year on electricity, couldn't it? And also the environment as well. The other thing is, I know that Philips, for example, are working on a screen. Most signage screens are about a G on the scale of efficiency, which isn't great, is it? That's like pretty much as bad as it could be. But what manufacturers are trying to do is use. A is the best. A would be the absolute best. Yes, sorry, G is terrible. It's just like GCSEs. So, what was I saying? What they're trying to do is lower power consumption, not just by making things dimmer, because that's no good, is it? We still need brightness. We still need to be able to see the image. But looking at the internal workings of the screen, is there anywhere we could save things on the computing? So we're looking at trying to get things down to an E rating in the next year or so, okay? So that to come. And the final bit of technology we've got on here is a 0 watt bit of technology. So again, if we can get something down from X amount of watts to 0, it doesn't matter how many that X is, that's amazing, isn't it? The way this sort of signage works is it only requires power to update the image, and then it's static. It doesn't change. So anyone got an Amazon Kindle here? Yeah. It works on exactly the same fundamental idea, that you update the image and it's static. But it's color, and it's a new launch that Philips have got going at the moment, but I know other manufacturers are working on things with exactly the same technology. And the idea is that you have an install of these across your shop. It wouldn't necessarily do the same thing as a high bright because there's no backlight on it, but it would work in a window if you've got sunlight to bounce off. And you can update them all at once using very little power. They can run off AA batteries. Like it's nothing. It's phenomenal technology. Come in a range of sizes, And we're expecting this to be quite a big thing, especially in shops that want to appear as eco-friendly as possible and can afford these big installs. Because at the moment, it's new technology. It will come down in price, but at the moment, it's at a price point where we're seeing big retailers interested. We'll see what happens with that in the future. Okay, so the takeaway from today, we've looked at 15-minute cities, getting things hyper-local, getting bespoke messaging for a community, hybrid working and weekday shopping. Remember, that's trying to make things appeal to the individual. Customer experience, creating these wow installs. And finally, sustainability, which you've heard about across the board in all industries, but that's what the AV industry are doing to promote that. So I think that's bang on lunchtime, isn't it? So thank you very much.
Thank you, Greg. Right, before you're allowed to go and maraud all over the sandwiches, does anybody have any questions for Greg? They're all too hungry to ask any questions. This is the trouble. No, Jason. Hang on a sec. Let's bring the microphone to you, my friend.
This is more like an observation than a question. Just going back to LED displays, these big displays that retailers use. What obviously some retailers don't understand is the amount of current that LED walls take. So if we start selling more and more of these big LED walls to retailers, they're going to use more current. That's going to drive up the cost of power. People are going to be paying more on their electric bills, and they're not going to the shops and buying stuff, right? It's counterproductive.
Absolutely, and it doesn't work with the eco message either, does it?
But the e-paper thing is interesting for sure. Yeah.
We'll talk about that later on then. Yeah. Excellent.
Okay, thank you very much. Any more? No. I think you've got away with it, like Greg. To be really honest, you got
perfect time just before.
Yeah, you got the best slot for not dragging. Okay, well, so in which case that brings us to the end of our formal agenda for today. I'd like to thank all the presenters, Pawel and Peter and Greg. I'd like to thank everybody for actually coming along, which is the most important part of all. Thank you to Rose for doing a lot of the organisation. Thank you for Jacob for doing some sound at the back there. And that's it. Please eat and be merry. Thank you very much. Cheers.